Hi everyone, today I'm here to talk about using sewer models to determine trade waste contributions to downstream corrosion. Before I start, I'd just like to acknowledge Graham Hamer and Joseph Cheska from Jacobs, who are also involved in this work, and Heath Georgia from SA Water. So today I'll just give you a bit of a broad context on sewers and corrosion, and then I'll move on to a trade waste investigation we did for SA Water, going through the objectives, the methodology and the results, and then I'll make some general conclusions and hopefully we'll have some time for questions. So the largest proportion of a water utility's asset value is in their pipes below the ground. Sydney Water alone has 27,000 kilometres of sewer pipes and 695 pump stations. And in Australia, there's greater than 110,000 kilometres of sewers. And these are worth tens of billions of dollars. So as you can imagine, sewer maintenance costs are significant and ongoing. But the good news is there's been a significant increase in the understanding of sewer corrosion mechanisms in the last decade, and we have a better ability to model and predict sulfide corrosion rates than ever before. So how does corrosion happen in a sewer? If you've got septic conditions in the sewage, the sulfates in this sewage can be reduced to sulfides by sulfate-reducing bacteria that live in the walls, in the biofilms on the sewer walls. This results in the emissions of corrosive and odorous gases, of which H2S is the major one. This H2S is then oxidized by H2S oxidizing bacteria that live in the crown of the sewer, producing sulfuric acid, which then leads to corrosion of concrete sewers. It's important to note that the H2S uptake changes based on piped material. Concrete's a very good sink and accounts for loss of H2S from the headspace through concrete corrosion. Conversely, in plastic line sewers, there's no H2S uptake, and the H2S moves along the sewer till it's either released or taken up by downstream concrete. So the ability to be able to model sulfide corrosion in gravity sewers and understand where this will occur is a key factor in the long-term asset management of sewers for water utilities. So what are these sulfide generation models useful for? Well, we can predict the level of sulfide generation, how it moves from the liquid to the vapor phase, how the airflow moves through a sewer, the biochemical corrosion mechanisms, and we can also look at the effectiveness of sulfide control chemicals. So now moving on to the SA Water trade waste investigation. The project came about because a trade waste producer approached SA Water and requested that they be able to increase the BOD in their discharge. So SA Water needed to investigate the impacts that this change in the discharge licence would have on the downstream sewer. So they engaged Jacobs to determine the contribution that discharge from the trade waste producer had on downstream corrosion and sulfide levels, and to investigate options for minimising the impacts on the sewer from any changes to the trade waste discharge licence. So this sketch here just shows you the configuration of the sewer that we were looking at. So the trade waste was discharged into a 4.2 kilometre rising main, which then flowed into a 2.2 kilometre vitreous clay gravity main, and then that discharged into a pump station. So the section of interest was the vitreous clay section, although its doesn't corrode itself. There were 15 concrete manholes along that section which were susceptible to corrosion. So now I'll just go through our methodology and results. First, we collected data and did some sewer sampling, and I'll talk about that on the next slide. Then we produced a calibrated model of the existing system using Jacob's interceptor model, and we fed the sampling results into this to calibrate it. And then we used the model to predict impacts from trade waste changes and assess the potential corrosion rates and what controls could be put in place to minimise impacts of this change in discharge licence downstream. So the data collection considered the trade waste discharge parameters, the sewer design, the materials of construction, and the current sewer condition. And one thing that was very important to consider was the potential presence of other significant trade waste producers, because we didn't want to assign corrosion and sulphide generation from them to the trade waste producer we were interested in. In terms of sewer sampling, this was undertaken to make sure that we captured the discharge from the trade waste producers. So we had to look at the times and discharge patterns for when this occurred. Then we took 6 liquid phase grab samples over 48 hours and analysed those for dissolved sulphide, pH, temperature, conductivity, dissolved oxygen, oxidation reduction potential, BOD and sulphate. And we also undertook H2S logging in 5 locations. We then produced a calibrated model of the existing system and then used it to predict the trade waste contributions to sewer corrosion using 2 methods. Firstly, we assigned domestic characteristics to the trade waste flow, and secondly, we removed the trade waste flow altogether. So you can see here in this plot on the right, which shows the corrosion rate along the length of the sewer. Initially, with the trade waste discharge in place at its current levels, the corrosion rate was estimated at up to 8 millimetres per year. Once we changed this trade waste component to either domestic flow or took it out altogether, the corrosion rate decreased significantly to less than 3 millimetres per year. The reason that putting the trade waste in as domestic flow had the lowest corrosion rate predicted was because this allows for some dilution, whereas removing the trade waste flow altogether doesn't do that. What we found was that the trade waste producer had a significant impact downstream and accounted for about 30% of the dissolved sulphide, 83% of the H2S, and 60% of the corrosion. So you can see that some form of control at their site could have a significant beneficial impact for the sewer. And the reason that the H2S levels the contribution was much higher than the dissolved sulphide is that there was a lot of turbulence generated in the discharge main from the discharge manhole from the rising main, which caused the sulphides to move to the vapour phase. These modelling results can also be useful for utilities to allow them to assign some of the costs associated with downstream corrosion and odour mitigation back to the trade waste producer. So after we'd worked out the contribution from the trade waste producer, we then looked at altering the trade waste discharge in the model to determine whether it was okay to change the licence requirements or not. So we looked at 3 different levels of BOD, 1,000 milligrams per litre, which is what their current licence requirement was, and then we upped this to 2,000 and 3,000. And as you would expect, the H2S and corrosion levels increased as the BOD increased. What we then did is we increased the BOD, but also increased the pH as well to reflect an increase in alkalinity. And what we found is that by increasing the BOD and the pH together, we could bring the H2S concentrations down significantly. And you can see in this graph here, the yellow and the light blue plots at the base with the lowest H2S concentrations occurred when we had the increased BOD and the increased pH. So we concluded that increasing the pH had a greater impact on the corrosion and H2S levels downstream than increasing the BOD, which was good news, because what we found is, so our conclusions were, if the BOD in the trade waste was increased, then the producer must also elevate the pH levels sufficient to overcome the fermentation in the rising main and the dilution effects of incoming flows. And if this higher pH was maintained in the downstream sewer, they'd be able to control sulfides, keeping them in solution and minimising corrosion and potentially odour problems. So as you can see, this modelling was really useful to provide SA Water with an indication of the controls that were required at the trade waste producer to enable them to increase the BOD in their discharge without causing detrimental impacts on the downstream sewer. So from our work, we were able to conclude that accurate modelling of the sewers does allow utilities to proactively estimate the true costs of changes in trade waste licences on their assets. This allows the utilities to determine whether the costs on assets are acceptable from a risk management and financial perspective, whether they think control measures are required, and then if those financial costs should be passed back to the trade waste producer. These models are also useful to the trade waste producer because they can decide if it's more cost effective to further treat their trade waste at its source prior to disposal, or whether to contribute to the costs associated with corrosion and odour control in the network. When using modelling similarly to how it was used in our project, it's really important that the time is taken to configure the model so it reflects reality as closely as possible. Sampling of the existing system is a really important step in achieving this and provides valuable data for model calibration. So as you can see, a proactive approach to trade waste management benefits both the utility and the trade waste customer, avoiding the negative impacts of corrosion on a utility's assets and odour on the surrounding community. So with that, I'd like to say thank you for listening, for staying up late or getting up early, and I'll have a bit of time for any questions. I'm sorry, I've just seen my son walk past behind me on his way to school. So I just saw a question from Jeff Mann asking, did we calculate airflows as well? Yes, we did look in the modelling that we did, looked at the ventilation rates through the sewer in working out the sulfide generated in the liquid phase and in the vapor phase and how that moved through the sewer.
This presentation is an introduction to the IEEE Sensors Council. Let's start by introducing the IEEE. The IEEE is the Institute of Electrical and Electronics Engineers, founded in 1963, a merger of two professional societies. It's headquartered in Piscataway, New Jersey. There are over 500,000 members worldwide of the IEEE in over 160 countries. Its mission is advancing technology for the benefit of humanity. The pillars of the IEEE: standards, globally recognized technical standards, we all know of those. Publications, over 200 journals. In addition, there are magazines, conference proceedings, over 2,000 of these technical conferences that are published around the world. All of those publications are available in IEEE Explore. It offers e-learning, certifications, professional networking, has local chapters and student branches all around the world. That's the IEEE. The Standards Association is an independent organization within IEEE. This is the website, standards.ieee.org. And from there, you can reach all the information about how to create standards and all the ones that are active. There are over 2,300 staff projects and over 35,000 participants around the world that are helping to write these standards. And here are some of the standards and you use every day in life. The Ethernet, 802, 802.11, Wi-Fi, the Bluetooth, floating point arithmetic, in every CPU and every computer, the solar wind to power grid standards, IEEE 1547, Internet of Things, the architecture and all of the devices and sensors around the world talking to each other. And here's some ethics in AI and autonomous systems. That's the IEEE P7000 series. So these are IEEE standards are an important part of everyone's life. Now, what about the IEEE Sensors Council? The IEEE's technical, the technical bodies, there are 39 technical societies: Computer Society, Power Society, Industrial Electronics Society, and 26 of those 39 belong to the Sensors Council. So the councils, there are 7 councils that are collections of the 39 subsets of the 39 members of technical societies. And the Sensors Council is one of those 7 technical councils, and it's the largest one. The mission to advance and coordinate the work of field of sensors and sensing systems, to work across all of these 26 societies promoting and sensor technology. The Sensors Council has the flagship conference, Sensors Annual. It has the ISOEN, that's a biannual odor monitoring eNose conference. It has Sensors Journal, Sensors Letters, conference proceedings, a number of other conference proceedings, develop standards, has tutorials, distinguished lecturers. So it has all of the functions that societies have, except it has no members. The members of the council are actually technical societies. And then in 2017, we established the IEEE Sensors Council Standards Committee. And now this particular committee can sponsor standards. We report both to the council and to the Standards Association, and we organize and standards projects, and we can publish them through the Standards Association. Where do standards range in the technology world? Research, disposal and recycling of products, everything in between are open for standards. And so standards can make early contributions all the way to deployment and maintenance.
Thank you very much. This presentation is about research undertaken at the University of Valladolid in Spain at the Institute of Sustainable Processes. This research was undertaken as part of my PhD that I performed over the last 6 years together with the group. And that has resulted in several publications and a thesis that I defended last April and was awarded with cum laude. And so I'm very proud to share some of the results. Now, due to limited time, I really would like to explain what is a capillary reactor and show some of the results of some hydrophobic compounds removed in a capillary bioreactor. These compounds different in hydrophobicity and different in biodegradability. So why this research? Now, for odor treatment or gas treatment in general, typical gas contact times of these systems are, for chemical physicals technologies, are several seconds. Now, biofiltration, biofilters by trickling filters are easily an order of magnitude larger in contact time. And so really very often especially for good removal of all the odors, gas mass transfer is limiting. Hydrophobic compounds, or the compounds of low concentrations, are a limitation for the microbes to degrade them properly. And so the research is here really about improving the the bioavailability, the mass transfer at first for the microbes. Over the years, several studies have been undertaken to overcome mass transfer limitations, and some are very interesting, really work well, but often specific for certain applications or certain types of pollutants, but often makes it very complex and not always good applicable. Now, the area that I wanted to research is capillary reactors. Capillary reactors are structures of small parallel straight channels, round or square, that are divided by a thin wall. And these capillary reactors have gained interest in process intensification over the last couple of decades due to their enhanced mass transfer as well as their improved reaction kinetics. Applications developed for especially the manufacturing of fine chemicals or pharmaceuticals, but also compact heat exchangers. Now, what is really happening is that these channels, only a few millimeters in diameter, both gas and liquid are flowing in the same direction. And if you change that ratio or the conditions, the speed or the liquid itself, you can obtain at a certain area the so-called bubble train or Taylor flow, where alternating gas and liquid gas bubbles and liquid slugs flow through these channels. Now, why is that interesting? That's interesting for two reasons. The first one is that this specific flow regime creates high turbulence. The liquid is recirculating in these slugs. That is because it flows through the channel, and on the side walls there's some resistance, and so you get an internal vortex that creates a very high turbulence. The second is that it has very low, relatively low pressure drop, and this is because of the capillary force. The channels are thin enough that you have capillarity, and we are all familiar with that. If you have, for example, here a porous brick and you place it in a shallow tray of water, over time you see that liquid pulling up, and that's exactly what is happening in these reactors. You see here gas bubbles with liquid slugs in between, and although this vortex you can't see itself, there is a high turbulence inside. This is slow motion. So really the driver here is improve mass transfer, capillary reactors. They can combine good mass transfer, relatively low pressure drop, and studies on these gas liquid capillary bioreactors are very limited. They are either undertaken in a single channel or only for a short period, and in general not focused on hydrophobic gaseous compounds. And so we wanted to understand the fundamentals and see how we can apply these mechanisms for removing hydrophobic compounds. Now, the way this was undertaken is building reactors, in this case glass tubes of about 1.5 meters in length, different internal diameters, but here it's shown as 2.4 millimeters, where gas is introduced at the bottom and it flows through the channel up, and where it is removed again. And then there is a liquid that is recirculated, and they are combined in the bottom reactor to create this so-called segmented flow. This is how these reactors look like. We've built several of them and operated under different conditions. Initially did a lot of abiotic experiments to map the flow regime of this so-called Taylor flow. It's relatively easy actually to obtain that. Done pressure measurements, pressure drops, mass transfer measurements under different conditions, and then also biotic experiments where we looked in the first instance to model hydrophobic compounds, hexane, toluene, and alpha pinene that we had operating for periods of several months. So here are some of the initial results. Operated at a very short contact time, less than 1 second, and we were able to obtain with these kind of concentrations, inlet concentrations, hexane removals of about 50%, 50-60%, toluene 90%, and pinene around 40%. But very robust, tested against some common upset scenarios, and showed really a good performance. So that was nice, but we wanted to also see if we can enhance that. And silicon oil was here applied So toluene, alpha-pinene, hexene removers were enhanced, and after silicon addition at a contact time of less than 1 second. So really nice results. And biomass here was adhered at the silicon oil phase rather than residing in the water phase. Overall, the treatment of hydrophobic compounds in capillary bioreactors is possible at gas contact times of only a few seconds, with or without silicon oil. And that's in the similar range of conventional chemical physical treatment. Now, another area that we looked at is methane, dilute methane. Approximately 55% of all the anthropogenic methane emissions have concentrations below 5%, and that's the lower exposure limit of methane in air mixtures, and are therefore incompatible for energy recovery or cost-effective abatement. And so we looked at these dilute methane, several 100 to 1,000 ppm, and treated them really effectively after some modifications to the liquid. Also after growing microbes that were adapted to the modified liquid. But overall, we obtained, I think, a world record in treating dilute methane in biofilters. It was really possible to have high conversion rates above 200 gram methane per cube per hour over a long period. And more importantly, we did not see any biomass accumulated on the walls of these channels. That was not only observed here with these high concentrations of methane, but also previously in other experiments like with the toluene, hexene, and pinene. And so it seems like that these conditions in these reactors, in these channels, create high enough shear stresses for the biological, for the biology not to attach to these walls. And so improving existing designs of bioreactors treating gases with this concept of segmented Taylor flow is promising and can open up new pathways for the abatement of not only polluted air, including odors, but also reducing greenhouse gas emissions, dilute methane, and also applying it for gas biorefineries, where really the bioconversion of gaseous mixtures, for example, biogas or methane into higher value products or biopolymers is really only feasible when this mass transfer is improved. And so with that, there's much more, but I'll leave it up to here, and if there are any questions, please let me know, or if you're interested in any of these publications. Thank you.
they grab an image from here and shove it on the side of the presentation. Is that what they do?
Well, unfortunately, neither Carlos, me, or anyone in this moderator session has control with. Carlos has given it to an independent company,
Yeah.
and they were meant to be managing it.
Oh, finally.
Okay.
All
We're
right,
live
so
now. We're
that's-
live.
yeah.
Did you want me here or did you want me in the other, using the other link?
Oh, well, so we're live, guys, now.
Yep.
So, yep. All right.
There's a slight delay.
Oh, well, thank you all for listening to Bart's presentation. Because it was a recording of discussing his subject, we won't be able to ask any questions on that particular presentation. So we'll be moving on to the next session. The next session is done by Geordie Galvin from Astute Environmental Consulting, and his topic is Swanbank, Key Learnings from Land Use Planning and Odor Complaints. Geordie, we welcome you to the MOM event.
I can start? Okay, very good. So I'm going to talk this morning about the Swanbank. Area is covered with things like that. Sorry, I'm just checking, making sure everything's working. Good. So it's quite undercut. So this is an example of a coal mine that had an underground explosion many years ago, but that whole area is undercut, and that's why it's good for a industrial area. So why is this topic interesting, particularly for our international watchers? Myself and Warwick both grew up in the area. I know there's complaints been going back to the late 90s. And certainly over time, there's been various investigations here that have changed the Environmental Protection Act, which is our state-based legislation. So anything I have to say here obviously has the benefit of hindsight, but the key thing is there were over 32,000 complaints from mid-2018 through to present, which is a fair few complaints. So back in 1975, the area was looking like this. Old coal mine voids. There's a power station here that was Swanbank A&B, which was a major electricity generating coal-fired power station in Australia. And just on the left here, I've got an area called Ripley and another area over here called Greenwood Village. And I've just marked them for all the images here so you can see them. But that is me back in about 1999, maybe, doing stack testing at the power station. So, yeah, I didn't travel far, and my parents still live up in here. Another view of the area, north to south, 8 kilometres, I said 10, 5 miles in imperial units. And you can see here the power station and all these voids. So by 2002, the area had transitioned away from mining back towards recycling uses. So here we have a landfill, and you can start to see some of these other uses here. So a lot of this is overburden as well. So there was spontaneous combustion occurring. So I've actually been out in this area even more recently, and you can still smell that sulfur smell from the coal mines and the spontaneous combustion. So, sorry, it's jumping way too fast. So where all this kicks off is formally in 2006, the local council, so our local area authority, created a new planning scheme, and that planning scheme set up the Swanbank New Chum Preferred Development Area. And it was located in close proximity to highways, so that was seen as a benefit. and it was classified, and I'm quoting from the planning scheme, as a flagship example of effective sustainable development integrated into surrounding emerging communities of Ipswich City. Now, hidden within, well, it wasn't really hidden, but within the planning scheme was the term difficult to locate industries. And when they talk about waste recycling is composting, landfilling, that sort of thing. So the planning scheme said waste recycling or treatment activities are discouraged unless it cannot be demonstrated with a high degree of certainty that such activities will not adversely affect any nearby residential areas, either existing or proposed. So with that in mind, that was in the planning scheme. The state odour guideline was first published in 2001, so that sets the odour criteria and limits that are used. Fast forward a few years, there was the Ripley Valley urban, I'll just skip to the, so in short, in 2010, 6 years later, the Ripley Valley urban development area was declared. So what that is, that basically says there's going to be significant residential development in the area. And that's the crux of the matter here, is that you have industrial uses in an industrial zone that's defined as an industrial zone. Those uses need to have a high degree of certainty that they won't adversely affect any nearby residential areas. And then all of a sudden you have significant encroachment. So if we come to the next image, there's the little Ripley Township, and this whole area surrounding the southern end of the Swanbank area is all set for development. And that's basically when the issues started to occur in this area with any significance. So by 2018, you had a series of landfills in the area. So this is on the northern end. I'll talk about this landfill in a minute. There's a capped landfill here and a couple of composting operations. And then this brings us to 2025. So by 2025, here's our Ripley and our Greenwood Village sites. These wide areas, you can see significant development. The population's gone through the roof in these areas, and something that wasn't really considered, I guess, initially was the development on this southern end of what's known as Redbank Plains. But the green lines here, I put them in because anything within those green lines is undercut, which means there's coal mines have been underneath. The circles are vents from old coal mines, old ventilation shafts, and the arrows, which may be hard to see, they're drives, so they show where the underground mines have gone and cut in under the ground. So you can see, in terms of land use planning, it does make sense to make use of that area for industrial purposes as opposed to residential. When we talk about this area and why there's been complaints, the predominant sources of complaints have been composting and all landfilling activities, and that's regulated by our state. So the state government regulates that, and they define them as what's called environmentally relevant activities. And they have a series of numbers and limit what can be performed. And this is an example on the left here of one I took the other night out of an environmental authority. So we get to the complaints. What do we know there? So in about 2018, the government set up a task force to look at the odour in the area. We first started doing odour surveys in the area around 2017, and the odour was there. It was readily detectable, certainly in the area immediately around the southern end. Predominantly composting odours at that time. By about 2020, 2021, you could go out in the area and it was noticeably less odour. So things were improving over time. And then in about 2022, a landfill flooded, and that caused significant issues in the area around it. Long story short, major rain event filled up a large cell, and that cell filled up with leachate. So the key thing is, of course, that you have nearly 33,000 complaints since 2018. This is an example, and I'll just throw this example in here. You have typically easterly and westerly winds in that area. So the Redbank Plains area here, and this is in 2018, when the lower complaints were. Redbank Plains is to the east, and these others are to the west and southwest. So different times of the year the complaints occurred, but effectively due to the encroachment, the complaints would have been expected, although not to the number that occurred. So this is a heat map in 2023 of the complaints, and the interesting part is obviously that there was a significant number of complaints, and unfortunately I was unable to source the original imagery. But these thumbs ups are places that in our normal travels we have smelt odour randomly, not associated with work. So I was having breakfast down here one morning, I think that's about 6 kilometres away, and I got a lovely waft of compost. Looking at the complaints over time, so left is what we call a compost dominated complaints. You can see the complaints on the southern end where you have the landfills and a couple of composters, large scale composters. And 2023 changed the mix. You were still getting complaints to the south, but you can see here where the landfill flooded and the complaints went through the roof. And that's when we got to about 8,000, I think it's 8,000 complaints in a year. That's just an image showing regulatory staff measuring hydrogen sulfide on the edge of this leachate on this pond here. You can see they're aerating. They were pumping out and then actually taking it off to a wastewater treatment plant for treatment. They did have hydrogen sulfide units in and around the community there, which I'll talk about in a minute, and there was a lot of hydrogen sulfide. There weren't any obvious trends at top level in the data. I tried to get updated data so I could dig into it, but there's no rhyme nor reason as to the number of complaints, and I'm sure there is within that, but it's just not evident at top level. So what's been done over time? There's been numerous attempts to litigate, numerous legal arguments as to how things work. A very simplistic example is if the regulator attempts to enforce something or historically and the paperwork isn't right, that can be challenged on a technicality. And underpinning all of this is that the environmental authority for the sites don't allow odour impacts at sensitive locations. And those sensitive locations are obviously houses predominantly, and with those houses getting closer and closer to the sites, they're stuck between a rock and a hard place in that they're within an area that's designated for that use, but the separation distances have disappeared. One of the main areas of argument has been which site causes the most odour within that area. And if you spend enough time in there doing odour surveys, you can start to differentiate between the sites, but it is an issue at hand. And a number of the sites have transitional environmental programs which enable them to move to compliance, which I'll talk about in a minute. So it's not as if since 2017 nothing's happened. It's a slow process. So what has been done, there's been interesting stuff done. There was an Odour Busters Odour Task Force, which started in 2018 and still going to a certain extent. There was a research report, a critical review, a legal review towards the end, and there's been monitoring over time. The Odour Abatement Task Force, big on social media, they do community events, field response to complaints, odour observations. Something interesting that didn't come out, they didn't really have a final report. A lot of the observations and things they did, I haven't seen them published, and I did want to show you their website, but it doesn't exist on the Internet Archive. I think there's a lot of stuff in there around data collection, training, method validation. There could have been a lot of work done there, and I'm thinking, so in one of our states here in Victoria, that they do a lot of field work, and I think probably some things could have come out of that around odour observations versus impact and risk. There was a research report in 2018 to which I would have called an annoyance survey. However, it was used questions around nuisance. It was opt-in, so they had 635 people opt in to do it, and then they randomly selected 800 people. And they used the question odour nuisance. How often have you noticed odour nuisance? What is the frequency of nuisance? What is the last time nuisance? And of that, 52% of people said that I'd noticed an odour nuisance, and 97% of the opt-ins said they had, which I don't think is surprising. Obviously, the surveys deviated from the standard odor practice we used to with odor surveys going back to the late 90s, early 2000s in Europe, and the work in Gladstone and subsequently done in New Zealand by Tracy Freeman more recently. And I think it would have been beneficial if this had have occurred to ask those few extra questions. And again, you could delve a little bit more information out of that. But the key point of the research report, irrespective of how it was done, was that it proved there was odour issues in the area, which I think was quite evident from the complaints in any case. But it did highlight that 50% of people randomly selected across the area had an issue or had noticed odour, and that didn't necessarily mean they'd complained. And I don't think that was delved out into in the report. There was a critical evaluation of composting operations and feedstock suitability project in 2019. These reports are all online, so if people want to find them, they're quite easy to find. The first stage looked at odour issues and had 29 recommendations, dealing with odour reception of liquids, avoiding leachate formation, aerating leachate, capping windrows with mature compost or green waste. There was a secondary report into contamination, because contamination of compost is obviously a risk, particularly with PFOS, PFAS in that area. They had 43 recommendations around waste tracking and revisiting legislation. So one of the outcomes or primary outcomes of this work in 2019 was that the recommendation was the DES, which is the regulator, should consider whether there is a need for more stringent regulation or conditioning. And there was a secondary recommendation as to whether DES should consider whether the current outcomes-based approach is appropriate. So with that in mind, in 2022, there was an independent review performed by Judge Jones and Susan Head, who's a prominent barrister here. And the scope of the review was to look at the adequacy of existing legislative powers for timely environmental performance and the adequacy of existing legislative powers and penalties for investigating and prosecuting operators. And considering the phase 1 and phase 2 reports before this, as well as the scope for the review, as we shall call it, it would appear there was an assumption that the tools and legislative powers were not sufficient. So the conclusion of the review was interesting in that the review established that to a very significant extent, the Environmental Protection Act already contains adequate powers and penalties to enforce obligations. And importantly, it didn't find any shortcomings or substantial differences when compared to other jurisdictions. And looking at the recommendations in the Arcadis phase 1 and phase 2 reports, there was a presumption that the regulatory powers weren't sufficient at that time. And the review highlighted that, for the most part, they were. There was a couple of things that were added in, linking odour and health, which I'll talk about in a minute. So they wanted to link odour and health because obviously DESI, as our regulator, don't manage health. We have a separate health department for that. The Act didn't define nuisance as serious or material environmental harm. And to put that in context, it was generally understood that if you had odour nuisance, it was harm, but it didn't necessarily fall into that serious category. Oh my goodness, I apologise for that link at the bottom. There was a recommendation to create a new offence of breach of the general environmental duty. There were recommendations to make environmental authorities easier to amend if a site was having issues. And interestingly, they recommended making conditions apply for the EA, which is the environmental licence, was cancelled or suspended, and to refine some of the statutory tools, which we won't go into here. Monitoring's been done over time, TO15 monitoring. These are SUMA canisters which have been put out, and for the purposes of the landfill to the north, they did do a lot of hydrogen sulfide monitoring. And of late, there's been some fairly significant movements in the area. 2024, DESTI, as they were then, announced a penalty of over $600,000 against a waste operator. And in the background to this, a number of these operators have been made to bring improvements online to reduce odour emissions, and that's more around in-vessel composting as opposed to outdoor composting. They should be fully enclosed, aerated floors, and that seems to be the way best practice has gone as a result of the reviews. And certainly, we haven't seen that in the complaints yet, but I expect as these systems move in there, the complaints should drop away. So there's been some good outcomes at the end of this. This is the EnviroSuite system, which was brought online in February 2025. They have put a number of weather stations, and here's our 2 reference points here, a number of weather stations in the area, measuring various things, predominantly hydrogen sulfide. There are some of these monitoring stations within the area here, which measure hydrogen sulfide, total VOCs, and ammonia, but they're not measured elsewhere in the community, and I think that would probably be interesting if they did do that. There is a public health inquiry afoot that's been completed to deal with the odour and health related concerns. There is a fair bit of information and around the community and how the community are impacted by continuous odour over an extended period, and the inquiry is to investigate the extent of health impacts. The report was due to be released by about now, but it hasn't been released yet, so I'm assuming it will be released sometime in early 2026. Coming to the end, what are the pros of having the SWAMBank estate and what's been learnt over time? Well, good use of mining voids and undercut land. Why not put recycling and other industrial uses in there? There were reasonable separation distances to start with, and the planning scheme supported the use. The con or downside to the area as it used was that the urban development area and preferred development area took away the buffers around the site. So it was enshrined in the planning scheme, but then the buffers disappeared. And that's how we got the conflicts occurring here. So, and one of the other questions is in the regulation up to date, is that you have 2 composters near to each other, and did they fit in isolation? Did they fit, when I say fit, did they comply with the odour modelling or whatever was performed? Did they fit in isolation? Did they fit separately? Which is the elephant in the room. Up until recently, it was seen as a challenge to define which of the 2 major sites on the south were causing the issue, and that's in the public domain information in the various court cases and things like that. So in conclusion, you have approvals for composters or recycling uses. There are the regulations sitting around them, and then there's a planning scheme that's supported them in the area. So the regulations were found to be okay. And then you have whether or not they're in compliance with the conditions, which talks about nuisance. Certainly the movement towards the controls in the previous slides is a good start there, and that should, I guess, quote unquote, fix things. There's a cumulative impacts of who, what, when, where, why, but as they move to control systems, that would be less of an issue. And certainly, as I've mentioned, they're moving forward. Mobile aerated floors, regulations have been strengthened, and something I haven't delved into here is that there were changes made to our state-based legislation based on Judge Jones and Susan Hedges' review, which has, I think, helped. And then just in conclusion, in hindsight, looking at this, thinking back to the late 90s when complaints started to occur with landfilling, was the science and legislation existing from the start? I think a lot of this was, and it's just lagged, and it would be a challenge for a regulatory agency to deal with this within the existing frameworks they have, particularly as this evolves fairly significantly over time. And I think there was some good learnings in there for research and actions and things like that, particularly around measurements and wins and stuff. And with the integration of AI into many things now, I think it would be interesting to see whether or not odour risk could be predicted or odour complaints could be predicted based on some of that information they are recording now. And that's where my presentation ends. Thank you for listening, and I hope it wasn't too quick and too mundane. Sorry, I'll have to unmute the microphone. It's not letting me unmute it. Nera, I've muted your microphone. I can't unmute you. Nera, I've muted you, but I can't hear through YouTube.
Okay, I believe that I'm here now. Hi, everybody. My name is James Hayes. I work at the Air Quality and Odor Laboratory, and I'm talking regarding the industry community nexus, how industry stakeholders engage with communities, odors, and each other. So let's see if I can get things moving. There we go. Okay, so most of this research has to do with biosolids and its interactions with communities. There are traditional drivers for how communities interact with each other, interact with the biosolids management, and okay, I believe this is one through odor. My name is James Hayes. Oh, I'm sorry, Naria, could you please mute yourself on this chat? Thank you. Talking regarding the industry community nexus, how industry stakeholders. This is very strange. I'm getting a strange feedback. Excuse me. There we go. Okay, so most of this research has to do with biosolids and its interactions with communities. There are traditional drivers for how communities interact with each other, interact with the biosolids. Okay, that should be working now. Okay, I'm ready to present now, I believe. Okay, I'm here now. Hi, everybody. My name is James Hayes. I work at the Air Quality. Let's see if I can get things moving. There we go. Okay, so most of this research has to do with biosolids and its interactions with communities. There are traditional drivers for how communities interact. Okay, I'm going to start presenting and I hope that this works. So there are traditional drivers and how those, these are ones that we've had for a really long time. Biosolids and other utilities have had these for decades. They refer to odors, urban encroachment, as you know, populations grow closer and closer to what were traditionally isolated utilities and services, as well as an increasing expectations of their environment. So as housing prices go up and other expectations regarding their local environment increase, communities have a greater expectation of what they believe, what their expectations are. However, biosolids has further considerations because there are now emerging challenges for community engagement. This refers to the changing relationship between water and wastewater utilities and its communities. Biosolids is a really good example of this because not only are you asking more of your communities, but the relationship is changing. It used to be water utilities would provide water, communities would provide waste, and that waste would just kind of disappear and you wouldn't have it anymore. There's now going to be sort of increased sustainability, and considerations where what you put down the toilet and that sort of things, or what's been how your waste streams behave will be put front and center, and a greater realization of sorry, a greater appreciation of, you know, where your waste is going and how it's being implemented. There are increasing health concerns to a certain extent. I believe personally that most of these health concerns are the fact that we simply measure certain contaminants that other industries don't. New legislation as a greater understanding of what is valuable, what is capable of being legislated within this space occurs. Increasing public scrutiny, and I believe that biosolids itself would like to become a market, and that will change the relationship between itself and communities. So we have to ask ourselves, is biosolids management ready to address these new challenges? So most of the research that looks into how stakeholders interact with each other within sort of industry community spaces typically look at communities, but we thought it would be really valuable to look at the other side of the equation. And you can break down non-community stakeholders into two broad groups. We have biosolids management, which is the exclusive space. This includes producers, contractors, managers, end users, that sort of thing. But then you have a greater industry community nexus, which consists of consultants, regulators, government. And this greater nexus is related to odor regulation, community engagement standards, and that sort of thing. And they're looking at more things than just biosolids. They'll be looking at all other similar utility approaches. We will, for this particular piece of research, be looking at the greater industry community nexus. And I think it's important that we appreciate how we understand what these domains do and how they interact with themselves, to understand how best to approach these emerging drivers and these emerging considerations for biosolids management. So how did we do this? We had a scenario exercise methodology, and I'd like to take the time here to thank Michael Asal for allowing us to do this at the 26th CASANZ conference in last year. And this consisted of three components. We had a workshop activity, presentations, and a reflection session. The workshop activity, we made small groups of varying numbers of different stakeholders, although we tried to include a regulator for each of those groups, and getting regulators here was a real boon for the research. And each group was given the same sort of materials and tools. After that, there was a presentation where each group presented in a couple of minutes their project plan based on the questions. And following that, there was a reflection session to assist in how we identified common themes between these groups and how things, how certain strategies were sort of grouped in together. This is just some of the tools that we provided. So at the top left here, these were questions that the group would ask the regulator of the group. So the question would relate to these are the factors that were being asked, and we provided a small description to explain what these particular factors were, and these were inputted in online. And then in addition, fictional scenario, what would be the rough capex, the rough opex, and all these other considerations. We also included a couple of very, very basic images here, which included odor unit boundaries, some windrows, where complaints were coming from. So all pretty straightforward stuff. There was also a brief description on the history of the site and its relationship with communities. So we found some really interesting things here, and we'll talk about them in more detail. We had the islands of expertise effect. We found that there was an enormous number of community engagement practices and an enormous number of odor amelioration practices for the site. Huge number, even for the group that we had. Most of these methodologies were largely reactive, and that's to be expected. But what I'd like to focus on for this slide in particular is that there was a really observed lack of inter and intra-stakeholder communication. So not only would you have, say, for example, the discussion and the sort of collaboration between consultants and regulators often be fairly constrained, but you would have different consultancy groups not really talking to each other very well, or the discussions between the sites or the consultancies, whatever it might be. Oftentimes those communication structures weren't necessarily formalized and often didn't provide the advantages or the capacity that they were looking for, especially considered to, practices from the past. So to give you an example of the number of different procedures and policies that were found, these are the examples of why isn't that working now? There we go. An example of the number of themes that were sort of discussed by all these different groups. And then we had to categorize those themes further to get some kind of structure as to all these different themes. The ones presented here are only the top 3 that were referenced for these 9 separate groups. We found somewhere in the region of about 70 or so separate themes for, a workshop exercise that was, very straightforward. And I believe they had about an hour and a half to conduct. So what we're finding here is that there is a tremendous amount of expertise and a tremendous variation of approach, which in some cases is beneficial, but as we'll sort of discuss, there are certain disadvantages with this system. So what I'd like to talk about now is what I call the islands of expertise effect. So imagine, rather than Australia being a landmass, imagine it as an ocean mass, if you like, and the communication between these different islands is rather limited, or not necessarily effective. Haphazard. Sometimes there's no communication at all. These islands, by the way, they refer to different consultancy groups. They refer to different governments at each level. They refer to clients. They're basically all these different stakeholders and their relationships with each other. So what do we have within islands of expertise effect? Most of the approaches are reactive, and there's very little in terms of proactive solutions towards community engagement, which would definitely lead to better outcomes. A lot of the knowledge that consultancies or experts within this field have is implicit. And what I mean by implicit is that it is based upon expertise. There's a reason why within the water industry, within community engagement spaces, that you have a great deal of value placed upon people who have been there for a very long time, rather than people who, come straight out of school or university or whatever it might be. And that is because the knowledge is developed not through any formalized structure, but through their own experiences. And that's a really hard thing to take away and sort of translate into more broader application possibilities. It's very valuable, it's very useful, but everyone's kind of doing it by themselves. And stakeholders have to rely on that. And it means that any one project has great ideas that produce results, but they're doing it in a bubble. And the other issue, of course, is that if everyone's doing things independently, it means that the capacity to establish best practice, the capacity to go beyond what is currently being pursued isn't really there, isn't really capable of being addressed. So what do I mean by sort of enhancing the ways in which community engagement can occur? And by the way, this is in no way limited to community engagement. That just happens to be my specialty. I suspect there are, for a matter of fact, I know that there are a lot of practices with regards to odor amelioration or training or CAPEX or whatever else it might be, where different tables provided very different results. And again, it's because of that lack of communication. But this is an example where below here, this is the AIP2 collaborative framework system. And the rough idea is that these are the ways in which you can group different community engagement practices. Up here are broad categories of what community engagement practices were suggested by the different groups within our study. And these are the types of community engagement that these themes of community engagement adhered to. So the overwhelming majority of what respondents said could be categorized as either reactive, or it refers to what is known as a knowledge deficit. So the idea is that if you want to make communities happier and more amenable to a local industry, all you have to do is educate them in some capacity. All you have to do is provide for them the advantages, show how great the technology is, and that'll make them more comfortable. Now, unfortunately, that doesn't necessarily work, and if it does work, the impact isn't as great as what we would like to see. And we have so many different, very codified, very well established other ways of having community engagement and providing much more efficacious means of community satisfaction, but we're just not using them. And the reason that we're not using them is because everyone is kind of doing it by themselves. And, in a very uncertain environment where I think to a certain degree, understandably, utilities are hesitant to try new things because they don't want to open up a Pandora's box of community concern. That you'll just stick to these, which will provide some capacity, some community engagement.
This presentation is an introduction to the IEEE Sensors Council. Let's start by introducing the IEEE. The IEEE is the Institute of Electrical and Electronics Engineers, founded in 1963, a merger of two professional societies. It's headquartered in Piscataway, New Jersey. There are over 500,000 members worldwide of the IEEE in over 160 countries. Its mission is advancing technology for the benefit of humanity. The pillars of the IEEE: standards, globally recognized technical standards, we all know of those. Publications, over 200 journals. In addition, there are magazines, conference proceedings, over 2,000 of these technical conferences that are published around the world. All of those publications are available in IEEE Explore. It offers e-learning, certifications, professional networking, has local chapters and student branches all around the world. That's the IEEE. The Standards Association is an independent organization within IEEE. This is the website, standards.ieee.org. And from there, you can reach all the information about how to create standards and all the ones that are active. There are over 2,300 staff projects and over 35,000 participants around the world that are helping to write these standards. And here are some of the standards you use every day in life. The Ethernet, 802, 802.11, Wi-Fi, the Bluetooth, floating point arithmetic, in every CPU and every computer, the solar wind to power grid standards, IEEE 1547, Internet of Things, the architecture and all of the devices and sensors around the world talking to each other. And here's some ethics in AI and autonomous systems. That's the IEEE P7000 series. So these are IEEE standards are an important part of everyone's life. Now, what about the IEEE Sensors Council? The IEEE's technical, the technical bodies, there are 39 technical societies: Computer Society, Power Society, Industrial Electronics Society, and 26 of those 39 belong to the Sensors Council. So the councils, there are 7 councils that are collections of the 39 subsets of the 39 members of technical societies. And the Sensors Council is one of those 7 technical councils, and it's the largest one. The mission to advance and coordinate the work of field of sensors and sensing systems, to work across all of these 26 societies promoting and sensor technology. The Sensors Council has the flagship conference, Sensors Annual. It has the ISOEN, that's a biannual odor monitoring eNose conference. It has Sensors Journal, Sensors Letters, conference proceedings, a number of other conference proceedings, develop standards, has tutorials, distinguished lecturers. So it has all of the functions that societies have, except it has no members. The members of the council are actually technical societies. And then in 2017, we established the IEEE Sensors Council Standards Committee. And now this particular committee can sponsor standards. We report both to the council and to the Standards Association, and we organize and standards projects, and we can publish them through the Standards Association. Where do standards range in the technology world? Research, disposal and recycling of products, everything in between are open for standards. And so standards can make early contributions all the way to deployment and maintenance.
applications within the industrial area. The main way we do this is by introducing odour modelling very early in the planning stage, long before any significant planning decisions are made. We're going to use the Wagga Wagga Special Activation Precinct, or SAP, planning process as an example in this study. One of the key things was developing live modelling. Now, this is where we create the model, run the model, and present the results on the screen in front of everybody in a workshop within about a 5-minute space. You need to create models to do that. It's not a particularly easy thing to do, but once you've done that, it helps a lot. What it allows you to do is rapid testing of different plans for the precinct and different land uses pretty much in real time, or within about 5 minutes, and it allows you to do a lot of work within a few hours, things that might take months to do. The key thing there is getting that information to the planners before major planning decisions are made. This is the study area we looked at in the Wagga Wagga example. It's approximately 8 by 5 kilometres in dimensions. The pink areas are in existing industrial uses. The blue is residential. There's quite a large town, around 50,000 people, just off the screen to the south. And there's the new heavy industrial rail line coming through the middle of this precinct. I won't spend too much time on model setup. A 200-metre grid. The interesting point is that each grid point can act as a receptor or an odour source. That's not normally done. A constant emission rate is used, just unity, 1 unit of emissions at the outset. And we're doing this per the New South Wales EPA odour policy, 99th percentile odour at receptors. It's a 2 odour unit criteria. Here's an example of the model setup. So these grid points can be a source or a receptor or both. The ones on the outside of the area can only be a receptor. That actually changed later, but there. A little bit of time on the scenario testing. We automated scripts that allow the models to run in real time while you're presenting. In less time than this talk, you'd be able to set up and run a model and present it. The odour contours identify areas of high risk for both sources and receptors, and you can do adjustments on the fly as you go. So here's how it looks. So on the left, the big picture is a concept layout for the precinct. The red is the high odour emitting industrial uses, and the green is the medium odour emitting industrial uses. These blue spots were all receptors. There's actually a hotel, resort, vineyard, and things like that in this area, and some houses. And you can see that for this plan, what's being planned on the left, a very large amount of that industrial area would be compromised and cause impacts. And these areas in the bottom right figure are the areas that would be impacted. And you can see that this vineyard and resort sort of area and these houses in the south were problematic, but also houses to the north. Optimizing that could be done in a few minutes in the workshop. In this case, we had a lot of money, so we purchased the properties. These blue receptor properties were acquired. We couldn't acquire things outside of the SAP boundary, so we had to use more traditional planning methods relative to buying properties. But you can see the outcome is much lower risk. If I scroll between those two screens, you can see a greatly reduced risk just by changing that thing. Now, this is one of many scenarios that were tested. The final layout, we did this not just for odour, we also did it for air quality and noise, and we ended up with this yellow buffer line. Every residence inside that yellow buffer line was acquired. The blue one here is a village of around 50 houses on a hill when we couldn't afford that. The more other interesting thing that came out of this was odour allotment. So this is assigning a set emission of odour as a land right or an entitlement per block of land. We're using the term of odour units per hectare. We back calculate to work out what that is, and you can calculate that for the whole area or per parcel of land or individual owner of land. Obviously, the most constraining receptor, the most impacted receptor is determining the allowance. And here's an example of how that looks. I might just zoom in on this one so we can see it a little bit more closely. You can see these are the odour allotments per hectare. They range from approximately 20,000 in the middle through to roughly 2,000 at the edge. And sorry, I can't seem to get out of this somehow. Not sure what I've done. Sorry, everybody. Okay. And yeah, moving on. So the key thing was that these maps went into the planning instruments and a whole set of rules went in there about how to do it. And essentially, if your development had less odour than allotted to the land, that's all you needed to do to prove acceptability, that you didn't need to do further assessment. If you exceeded that, then you needed to follow the normal route where you would get a consultant to do an assessment. These odour maps are in the master plan, they're in the delivery plan, and we also zoned residential areas outside the precinct and things like that to be able to maintain the buffers. The example here demonstrates how odour modelling at a very early stage can inform better strategic land use planning, how it can be integrated into land use design and policy. It provides clear buffers and criteria for industry up front, so you know how much odour you can make from your lot of land. It can streamline the application process. I should have explained that you can actually trade odour. So if I go back to the earlier slide, you know, a block of land here may not use up all of its odour, and it could trade with a block out here, but there's a 10-to-1 difference in that. So it's a bit like an exchange rate between blocks and things like that. So you can do things like that. It's a template that's been used in other precincts, a list of them at the bottom there that have been done so far. Mamoi is a large area. It's approximately 650 odd kilometres by 250 kilometres. So that's the size of some of the smaller European countries. But we've been doing this with mine planning and operational management of mines, large ports, infrastructure, and even things like forensic toponymy. Anyway, that's the end of my presentation. Thank you very much.
Hope you enjoyed Alex's talk, and we will be moving on to the next presentation, which will be on development and application of comprehensive methods for odour dispersion modelling and calibration using separation distances determination. So, Andrew, welcome this morning, and look forward to hearing your talk.
Thank you. I'm going to try and share my screen. screen. I think this might share it. Let's work out the technology. Can you see my screen?
Yes, we can.
Yeah, we can. Okay, fantastic. All right, g'day everyone, wherever you are in the world, and welcome to this presentation on developing site-specific odor industry receptor separation distances. I'm Andrew Balch from Air Environment in Australia, and my collaborator on this project was Prasha Vijayalan from Taswater in Tasmania, Australia. I'll be sharing our collaborative work on developing and validating a scientifically rigorous method for determining evidence-based buffer distances using one of Taswater's wastewater treatment plants as our case study site. Our case study site was an urban wastewater treatment facility situated next to an estuary. The facility operates a secondary activated sludge treatment system with chlorine disinfection and comprehensive odour control measures. The plant services approximately 22,000 EP with a current average daily inflow of 4,470 kilolitres per day, which is well within its licensed capacity. The treatment process encompasses primary and secondary treatment, anaerobic sludge digestion and biosolid dewatering and storage facilities. The facility's urban and estuarine location presented typical challenges for field odour assessment and management with sensitive residential receptors in close proximity, inaccessible private property and water limiting survey locations, and complex meteorological conditions influenced by both terrestrial and marine atmospheric boundary layer processes. The plant has a mixed odour control approach that's typical of Australian wastewater treatment plants. What makes this particularly interesting for our method development is the contrast between, is there a problem with the YouTube? Is there a problem with the feed, is there? Someone's asking a question, I think.
No, we can hear you loud and clear. You can continue.
Okay, fantastic. Sorry. The plant has a mixed odour control approach that's typical of Australian wastewater treatment plants. What makes this particularly interesting for our method development is the contrast between controlled and uncontrolled emission sources within the same facility. The primary treatment area, including the inlet channel and 3 sedimentation clarifiers, is fully covered with air extraction for odour treatment in 3 biofilters. However, during the emissions audit, these biofilters were determined to be significantly underperforming and responsible for 97.8% of total plant odour emissions. This constitutes a non-routine emission source, which actually helps to assess odour buffers, which are typically required for the mitigation of impacts associated with non-routine residual emissions rather than normal emissions. In contrast, the secondary treatment area tanks, the selectors, anaerobic and aerobic zones and clarification are open to atmosphere, creating odour sources. The anaerobic digester air gases are flared for both safety and odour management, while the sludge dewatering building is ventilated to biofilter treatment, and the sludge storage bin is covered and ventilated to an activated carbon filtration system. Importantly for our research, this situation created ideal conditions for methodology validation because we're able to test our approach against both controlled and uncontrolled emission scenarios within a single facility. We collected 66 odour samples with minimum triplicate sampling across all treatment areas. Biofilter surfaces were sampled over 4 zones, inlet channels as a time series during peak flows, and secondary treatment tanks repeated over 2 days. All samples underwent odour concentration analysis by dynamic olfactometry and qualitative characterisation. Our dispersion modelling employed Tapham Calmet Cowpuff suite with a representative meteorological year. We statistically validated meteorological model performance and developed comprehensive emission inventories comparing multiple previous audits. Multiple scenarios assessed entire facility and individual odour source groups with sensitivity analysis revealing suboptimal biofilter performance. This slide shows the predicted ground level odour concentrations for 2 key odour source groups. That is the sources which have similar odour characters when observed downwind. That is similar within each source group. Each source group is obviously different, the primary and secondary treatment areas. We then conducted 15 two-hour ambient odour surveys over 5 consecutive days with coverage between 6 a.m. and 9 p.m. Each survey lasted over 2 hours using 5-minute measurements at 10-second intervals. We recorded odour intensity, hedonic tone, meteorological conditions and odour character, and identified source information. This slide exported directly from our Plume Mapper software illustrates all of the 156 measurement points collected over 15 surveys. The colour coding relates to the observed odour intensity. The site boundary and odour sources are all shown on the map. You can see in the map that white dots represent no odour was detected, yellow is very weak, green is weak, and blue dots are moderate or obvious odour. Using Plume Mapper, we can easily filter the observed odour data by source or any other combination of measured parameters and calculate the maximum odour footprint. Plume Mapper also presents data graphics like this box and whisker plot, which shows the distribution of downwind distances in which odours were observed at different intensities. The slide shows the spread of odour observations and the odour footprint, that's the contours, of the primary treatment area odour sources. Here you can see the spread and odour footprint of the secondary treatment sources. Well, this slide shows the spread and odour footprint of all plant sources combined. The field odour surveillance data suggests that the odour modelling may overestimate the plant's odour footprint. So we can ask ourselves some questions. How does this odour footprint compare to the odour model predictions? Are the field observations representative of the highest impacts modelled for the 99.5th percentile? That's according to the local regulatory odour criteria. Are the field observations conducted at the worst case time of the day or the year? And do they capture the impacts under worst case emissions and or meteorological scenarios? So we moved on to a model validation. This is our next critical step. To ground truth the dispersion model using our field odour surveillance data. We modelled meteorology for the survey period, assimilating survey observations at sub-hourly time steps to capture local atmospheric conditions. We then modelled our odour emissions inventory from the survey for each 2-hour survey period and systematically compared model predictions to field surveillance observations. This comprehensive validation approach allowed us to identify discrepancies between laboratory-derived emission rates and actual field conditions, providing the foundation for model calibration and scaling factor determination that would enhance prediction accuracy. Our model evaluation revealed systematic discrepancies between predicted and observed odour impacts. The dispersion model over-predicted the impact of primary treatment area odour source emissions, while under-predicting secondary treatment area emissions. This raised critical questions. How significant were these discrepancies? Could we correct them systematically? And crucially, were our field observations representative of peak impacts, or at least the percentile values that align with regulatory assessment criteria? For example, in this case, the 99.5th percentile. These findings highlighted the importance of field validation in odour assessment methodology. To address these discrepancies, we applied the European Field Ambient Odour Plume Measurement method for our observed odour footprints. We defined one sniffing unit odour isoplex representing the detectable versus non-detectable boundary for each odour source group by character. We then compared observed one sniffing unit isoplex with modelled concentration isoplex, establishing that one sniffing unit equals one odour unit for calibration purposes. The contour on each of these plots represents the closest modelled contour to the one sniffing unit line determined from the field observations. We calculated source-specific scaling factors through systematic comparison of observed and modelled plume boundaries. We determined mean scaling factors for each source type. The average emission rate scaling factors revealed significant discrepancies. For instance, the primary treatment area odours were overestimated by approximately a factor of 4. Secondary treatment area odours were underestimated approximately by a factor of 7. We developed a full year model using our validated Tapham-Calmette cowpuff configuration and applied the ground truth emission rates incorporating our scaling factors. We identified the furthest field measurement locations where detectable odour was observed during our field surveys and extracted annual concentration time series at these critical receptor locations. This approach enabled us to determine the percentiles where concentrations exceeded our assessment criteria, forming the basis for evidence-based buffer distance determination. Here you can see the difference between the original model, 2 odor unit for the whole plant, and the now calibrated or modified model. We generated concentration isoclefs for various percentiles using either 2 odor unit concentration criterion or equivalent to moderate or obvious odor intensity as options. We then calculated statistical distributions of source to buffer distances. This analysis showed a primary treatment maximum distance of 557 metres versus a secondary treatment maximum of 457 metres, with area equivalent radial buffers of 274 and 226 metres respectively. These figures illustrate the evaluation of alternative buffer approaches such as conservative concentration-based percentiles, area equivalent radial buffers, and actual meteorologically adjusted buffers. We selected the most appropriate approach considering sensitive receptor distribution and regulatory requirements while keeping in mind the uncertainties in the measurements and consequent scaling factors. You see on the left, the image on the left shows the primary and secondary treatment plants. That's based on the model of the distribution of winds. And then if you take those areas and make it area equivalent, but make it a radial buffer, you get the buffer on the right, which is a more typical static buffer a distance for a treatment plant. But it obviously ignores the prevailing wind directions. We then compared the calculated site-specific buffer to the actual state's existing regulatory buffer. The regulatory buffer is a static 400-metre radial buffer from the site boundary. In this image, we have meteorologically adjusted all the buffers for comparison. This retains the buffer area while skewing its shape to account for meteorological biases. In this case, the regulatory buffer is more conservative in all directions except for the direction of the prevailing wind to the southeast of the plant. We've acknowledged several limitations requiring enhancement for broader method application. We identified the need for expanded temporal coverage across multiple seasons, increased survey frequency, and laboratory-based odour concentration intensity relationship characterisation using the VDI 3882.1 protocols. Enhanced spatial coverage requires multiple assessment teams and better land access to survey locations. For transferability in the wastewater sector, we must develop wastewater treatment specific calibration protocols and scaling factor databases across facility types. This methodology just demonstrates significant scientific rigour through ground truth validation, combining laboratory emission testing with field observations. Our advanced cowpuff modelling integration using 10-minute time steps and European ambient odour survey method, plume surveillance methods, provides systematic model calibration, achieving reasonable regulatory alignment, deriving 274 metre versus 400 metre planning scheme standards, while providing site-specific refinement based on actual emission characteristics. This standardised transferable framework bridges the gap between generic regulatory buffers and facility-specific separation distances, enabling cost-effective risk management that prevents over-conservative restrictions while providing defensible compliance distances with comprehensive quality assurance protocols, ensuring reproducible results across industries. Thank you. Thanks for listening.
Yeah, thank you, Andrew. If anyone's we've got a couple of minutes for questions. If someone wants to ask them through the YouTube chat, in order for the YouTube chat to work, you will need to log in with a Google account. So if you've got any questions for Andrew, please put it on the chat form. Okay, I don't think we've got any questions there. Thank you so much for your time, Andrew, and your presentation.
Thank you, Michael. Thank you.
Ruth, we now get Ruth Fisher to introduce the next speaker.
Hello, everybody. Hopefully you can hear me. So our next speaker is Thais. Hopefully I've got the right order. And she'll be talking about some of the work that she's been doing as part of her PhD, looking at the sensory perspectives of food waste and why we should consider this when we're designing our new systems. Thank you.
Can you hear me? And can you see my screen?
Yes, we can.
Looks good.
Is it on full screen mode?
No.
No.
Oh, we can see it. Yes.
That's better.
Your screen is working. Yeah.
Okay, so I think I'm going to start. I have the YouTube open in another screen here as well. So my name is Thais Guerrero. Just submitted my PhD a few months ago. I was one of the lucky people that got to do a whole PhD on odor, and in particular in terms of biosolids management and odor challenges. And now I'm working as a research associate here as part of the Odor Laboratory and the Water Research Centre at UNSW Sydney. And I was supervised by Ruth, Richard, and Ademir. And today I'm going to be talking about part of my thesis, which was on this particular part, as Ruth mentioned, was on odor challenge in anaerobic co-digestion and focusing on food substrates and food waste. So when we talk about biosolids and biosolids management, sludge is a byproduct from wastewater treatment. And before it can be reused, we have a number of steps to make it safe and in particular odorless, which sometimes are not great, but we can have some sort of pre-treatment, which you might have heard of thermohydrolysis, and then biological, chemical, or physical processes. And I have a few examples there, such as anaerobic or aerobic digestion, composting, alkaline treatment, and thermodrying. And then this product is now called biosolids, and it can be reused, for example, in land application. And in Australia, we use around 85% of biosolids to land. And it has a lot of benefits for the soil, agriculture. However, this product can be deodorant, and that's what my PhD was trying to understand of how these different biosolids processing steps would affect the odor outcome from biosolids. But today I'm going to be mostly focusing on this emerging technology, which is anaerobic co-digestion of wastewater sludge when you add an extra waste stream, which can be food or beverage, or there's actually been a lot of research in the last decade and investigating industrial farming, agriculture, or municipal waste materials. And now it's been emerged as an alternative method for biosolids management. And a lot of this research are looking into how it affects operational parameters, or what's the, for example, risk of trace organic contaminants and different aspects of this emerging technology. But in particular, my research, what's the technology on odor? And it was the first attempt to comprehensively study odor emissions from the anaerobic co-digestion of municipal wastewater sludge with food waste and beverage waste. And the interested in this new technology is because there's been benefits observed, such as that improves digestive stability and biogas production. However, we were concerned what would be the odor impact of this process, as odor management is already a challenge in biosolids management. And these co-substrates are unsatisfactory in meeting market standards, so expired, contaminated, or damaged, designated for disposal. So another waste stream. And how the study was conducted, as I mentioned, we had different types of waste, and today I'll be focused on the food. Two pilot scale 1,000-liter digesters operating in parallel with similar conditions. One was going to be co-digested with these different materials separately, and then one control to see what's the difference in terms of impact. And then we extracted from the samples using microchamber thermo extractor we have here in the Odor lab, and then analyzed for sulfur using GC-SCD, and then 10x sorbent tube for GC-MS. And it's important to highlight that both of the digesters had achieved steady state conditions for volatile solids removal and biogas production prior to the odor emission assessment. And then we look at, in terms of odor, what we look at analytical methods. So what's the chemical composition of the odor coming out of these co-digested and control samples, but also what's the sensory impact? So what's the perceived impact of the odor in terms of human perception? And the GC-MS plus ODP, so the odor detection port, it's very useful to identify individual odors in complex gas mixture, but also evaluate their potential sensor impact. And in terms of sensor impact, we had two different types of food waste added at 10% ratio. So 10% food waste, 90% sludge. And they were from different sources. Food waste was from cafeteria leftover meals. And then food waste B was restaurant discarded food from cooking and meal preparation. And we observed that they had kind of a similar increase in terms of odor events, 8 and 7. But in particular, we're not only interested what's the increase, but mostly we're very concerned when we have a odor event that was non-detected before, and now it has been detected in this new process. And that was particularly important for the food waste A. And these modified frequency, which we are showing here, it considers both the frequency and intensity of odor events. So these odor events that increase, they could be either they are more frequent now, or they are higher intensities. And then we also look at different feeding ratios. So if we add, instead of 10%, now we have 20% feeding ratio, what would be the impact in terms of odor? And we actually observed that if we double the ratio, we actually double the increase of odor events as well. So there's clearly an impact on adding these co-substrates into the digesters to odor outcomes. But then we also looked at chemical composition, and we detected 209 volatile organic compounds. And from those, we prioritized 16 as potential odorants of concern, which we'll see in the table. And in particular, that is a significant increase. And not only for hydrogen sulfide, but other sulfur precursors. They can occur naturally in food. They can be used as food additives to preserve color and prevent microbial spillage or result from fermentation. So these precursors are likely causing this increase in emissions from the addition of food waste. And then when we looked at other sulfur compounds, we also had a high detection frequency for all compounds but methyl mercaptan. And so other non-H2S sulfur compounds can be important when assessing odor impact of co-digestion. A lot of the monitoring sometimes involve just H2S, and we observe that other sulfur compounds and other volatile organic compounds are also important in terms of odor. In particular, in terms of volatile sulfur compounds, methyl mercaptan, dimethyl sulfide, dimethyl disulfide, and dimethyl trisulfide. And just some conclusions. This is a short snapshot from the full paper that's been published, and it's part of my thesis, but the introduction of co-substrate amplified the unpredictability in volatile emissions. So we observed a higher variability in terms of emissions when we compare with the control. Likely because we have inconsistent source of substrate, the different wastes that were added, they're likely going to vary over time, and that's likely to disturb the digester. And also there might be insufficient adjustment time in the digestion processes, even though we saw steady state conditions for volatile solids removal and biogas production. And then the presence and degradation of the precursors introduced by the co-substrates. And then in terms of overall conclusions, as I mentioned, this was the first attempt to study the odor impacts of co-digestion. So before the introduction and choice of substrate mixtures, there should be further study, so carefully study before full implementation, because you can have odor, like increase your odor in problems, and then GCMS with the sensory is a valuable method to provide both olfactory and chemical information on treatment performance and nuisance impact. And by having this information can be useful when optimizing digester performance to reduce nuisance impact, because we want to make odor a operational priority, not just a kind of inconvenient byproduct from the wastewater treatment or biosolids management. That's it from me. Thank you very much, and happy to answer any questions that you might have.
Thank you, Thais. The questions will come through YouTube and the YouTube chat.
Okay.
If anyone has any questions, you're welcome to submit it via the YouTube chat. Just a friendly reminder that you will need a Google account in order to be able to ask the question. I'll let you take over, Ruth, when you're ready.
Sounds good, thanks. I'm not sure if, oh, there was a question from Bart, if Thais is still
I'm
online.
still here.
Great,
Yeah.
or maybe you'd like to answer the question from Bart. It was, would there be any specific food sources that you would recommend not to add?
So I guess what we saw from our research was that first we need to further study this, but in particular in terms of food waste, I would say it was the worst outcome we had, because I didn't show the results for the beverage rejects here, but they actually improved some of the odor emissions. They reduce, but in terms of food waste, I wouldn't recommend adding them at this stage. At least we might be able to optimize operational conditions, but yeah, not from our study.
Yeah. Yeah, that's great. So yeah, composition changes can be a challenge. So I think we're ready for our next presenter, I believe, who will be Leisha. And she's also originally from UNSW, but has since almost graduated from her PhD. She'll be coming and talking to us about some of the sampling methodologies. So looking at the influence of different sampling methods, specifically with flux hoods, and how they can influence odour emissions. So I'll pass it over to Leisha. Thank you very much.
Thank you, Ruth. I'm gonna share my screen. Can everyone see my screen?
Yep, I can see it.
Cool, great. All right, good morning, good evening, everyone. I'm Leisha. As Ruth said, I was a PhD student at UNSW, and I submitted my thesis last year. I had a very wonderful time with Thais, Ruth, and Richard at UNSW, and now I'm a odor engineer at Stantec working with Ari Shaman. So today I will discuss the repeatability of flux chamber measurement for odor emission, and going to ask this question: what we are really measuring. So as we all know, odor emissions are a common concern across feedlots, lagoons, chicken farms, landfills, wastewater treatment plants, and the soils. And this source release a complex mix, such as hydrogen sulfide, volatile organic compounds, volatile sulfide compounds, ammonia, and methane and carbon dioxide. So over the last decades, there are a lot of methods has been developed, which are in common practice, including sampling devices, portable analyzers, and meteorological methods. But there are still some concerns which related to odor sampling methods, which the influence of sampling methods on emission is unknown. So this is part of my review paper over 150 sampling papers, and the results are showing in the few sections. So over the past decades, a range of the sampling methods has been used in scientific research and engineering practice to estimate the gas exchange at the porous media. However, there has not been a consistent nomenclature to represent the different sampling methods. For example, a variety of the terms has been used to denote an enclosed sampling chamber without consistent sweet flow.
Sorry to interrupt, Leisha. I don't think your slides are changing.
And I'm in the slides which showing all the sampling methods.
No, we just see the original slide deck. Maybe if you just click on the slides that you're going through one by one rather than presenting it, I think it will go.
Cool, thank you.
Perfect.
Sorry for So in these slides, so as I said, we have been reviewing a lot of papers, and there's not a consistent nomenclature on the sampling techniques. And for example, you have seen a name such as a closed flush chamber, or closed static chamber, or static flush chamber, or even static hood has been used to represent a same sampling devices that's without a consistent flush flow. So I understand there's no point here in arguing for correct term, but we still become clear that the inconsistent naming can be a source of confusion and misunderstanding. Therefore, this figure establishes a basis of consistent nomenclature. And you can see the sampling methods has fall into two border group, which are directly sampling methods and also hash-based methods. So direct sampling methods contain flush hood, wind tunnel, and static chamber, which are all the open bottom devices can be placed over the sample in the laboratory or in the field. Hash-based methods, which include dynamic hash-based and static hash-based, are all the methods which represent a closed container and where the sample will be put inside for sampling. I will go next slide. So according to our discussion last slides on the variety of the sampling methods, there was always a question about what led to the diversity of the sampling techniques being used. For example, if a specific sampling technique was selected because of its lower cost, popularity, or mechanistic advantage in being more suitable for using in specific sources. So to better clarify these motivations, we have reviewed 150 papers focusing on odor sampling from passive areas, from area sources, including passive and active. And of these papers, 60% of didn't provide a rationale for the choices of their sampling methods. Only 35% of the paper has given a reason, and the reason has been grouped into three categories, which are here. So for reason one, we would say it's mechanistical reason. For example, like wind tunnel is a common method because it's able to simulate the wind action. And for reason two, the paper we have concluded as a practical reasons. For example, static chamber is selected because it's simple and low running cost. Reason three, we would like to say it's mainstream reason, specifically for flush hood, which is the most popular and widely used method because we have guideline for its operation, which is simple and easy. So clearly we can say mechanism and popularity were the two main significant reasons attributed to the choice of the sampling devices for capturing gases from different area sources. So even within one method, emission results vary widely with operational parameters. And there are some key influencing factors such as sweep gas flow rate and the insertion depth of the chamber, fan speed, and mixing efficiency, and also incubation conditions for the hash-based methods, including dynamic hash-based and static hash-based. This metric figures summarize the main influencing factors for the different sampling methods and the recommendation for mitigation actions. So there are some high affecting factors, for example, for insertion depth, which is considered as a high infecting factor. So the way we to mitigate the effect of the insertion depth is trying to minimize the depth as much as possible, as long as we can ensure that good seal condition inside the chamber is well maintained. Same for the sweep flow rate. When we are doing sampling, a suitable sweep flow must be selected, not too high to dilute, and also not too low to let the gas accumulate inside the chamber. For the low affecting factors such as the presence of the fan or the fan rate, we also have related actions to mitigate the impact. So if a internal fan is not really needed, if you can say a headspace of the chamber is well mixed, but if you really want to use a fan and to you need to make sure the fan speed, position, and specification must be clearly recorded and keep consistent while you are doing the sampling. Overall, the message from this table saying the method repeatability depends not only on the device type, but also on how consistent these parameters are controlled and reported. To investigate the repeatability of the flux chamber, we have set up the experiment in the lab with a control environment. So this left bottom schematic shows the setup of study VOC emission from dry porous media surface, in which a layer of the porous media is suspended above a liquid layer which acts as emission source. The non-concentration of the target VOC were added into the liquid layer. In this research, we have two chemicals has been selected, which are relatively stable and commonly detected from area sources. They are acetic acid and butanol. And we also selected 3 different type of solid, which depending on their porosity, organic compounds, and they are sand, cocoa coir, and soil. They are super easy to find from a local supplier. And from this experiment setup, we also have a feed chamber with adjustable sweep flow from 1 liter per minute to 5 liter per minute, and also with a mechanical mixing fan, as well as adjustable internal volume of the chamber from 20 liter to 29 liter. And here are some basic results from this paper. So you can see the relationship between the sweep flow rate of the flux chamber and the VOC emission rate. So generally, all the results exhibit a uniform trend where the emission rate will increase with a higher sweep flow rate. That makes sense because when you have a higher flow rate, you're gonna generate more turbulence in the surface of the dry media, which gonna improve the mass transfer of the gas. That's why it lead to a higher emission rate. Well, when you look in deeper, in the case of the porous media, the emission from the cocoa coir showed the greatest sensitivity to the sweep flow rate, while flux of acetic acid and butanol increase around 25 and 11 times respectively, when the flow rate changing from 1 liter per minute to 5 liter per minute. And in the case of the target compounds, if you can see, the acetic acid represent a more significant response to the changes in the sweep flow rate instead of like a butanol across all the media. The most notable increase in emission rate was observed in acetic acid emission from cocoa coir, which in the red line here on the right figure, where the emission rate at 5 liter per minute was substantially higher than at lower flow rate. We also have done some tests regarding the relationship between the headspace volume of the chamber and also the VOC emission rate. So the result has shown a general trend where the emission rate of butanol and acetic acid increase when the headspace volume decrease. And in particular, emission rate of butanol and acetic acid from sand, which are highlighted in red circle, had a sharp rise, where the butanol and acetic acid increase around 100% and 70% respectively, when the headspace volume was reduced only by 5 liter. So in contrast, emissions through cocoa coir and soil were not as strongly related to the variation in the headspace volume, where only limited changes was noticed for cocoa coir and soil, which means maybe which means the emission rate from sand or cocoa might be sensitive to other factors, not only by the headspace volume. Then follow this conclusion, we have also done the comparison between fans. And here, based on the different mechanical mixing scenario, we have namely the no fan, small fan, and bigger fan. As a trend, you can see the emission rate of both butanol and acetic acid has increased with the presence of fan, and the growth was more pronounced from the surface of cocoa, which is sit in the middle of each figure. Installing the fan can increase the emission rate. From the result, we can tell, however, the increase depending on the fan's capacity to promote adequate mixing in the headspace and create more turbulence. And this turbulence depending on the fan speed, fan size, and also the direction of the fan. Follow on this, the preliminary result we have shown here, and there are some discussion and results. So firstly, we'll say the odor management result highly depending on the sampling method and parameters, and which is an important factor, but many study has lack of justification and standardization. And in the experiment of the flush chamber testing, we have identified the flow rate as a dominant measurement outcome, as well as a mixing. So moving forward, there are some steps we would like to suggest you to improve odor sampling from area sources. So firstly, it will be develop standard operating protocols for chamber design and testing, and then follow with require full reporting of flow rate, chamber volume, temperature, and mixing when you are doing sampling. Thirdly, it will be a good idea to establish calibration procedure using non-emission sources and encourage inter-laboratory comparison studies to quantify methods uncertainties and get a more accurate result. That's all my presentation today. Thanks for having me, and I would love to take any questions.
Thank you very much, Leisha. There's a little bit of a delay, so we'll wait for any questions that are coming through. And I think in the next session after this, we're going to have a round table where we'll pull lots of people together.
I'm very surprised there's no questions, which is such a contentious subject. I mean, it's the laws of diffusion and mass transfers. So I encourage anyone with that probing, if there's any questions on Leisha's talk.
Always just emphasizes how complex odors are, having to deal with liquid and gas and solids and everything all mixed in together.
100%. And the complexity of all the different vapor pressures, all the various compounds that we know of, mind you. There's still the balance and the other components. Alrighty.
Oh, well, we'll keep an eye on the chat if people have any questions, and we can answer them later.
Yeah, absolutely.
Otherwise, great. Thank you very much, Leisha.
Cool. Thanks, Ruth.
Thank you, Leisha.
Thank you, Michael.
Okay, so we've now moved on. We've gone through all the talks for Australia and New Zealand, at least for the Oceania region, for the MOM event. The next program in the agenda is to do a roundtable, and during that roundtable discussion, we'll be including both the speakers and moderators of the session. The DNA of the group that includes the moderators and speakers are a good composition of Australia and New Zealand professionals. It's a great opportunity to have a roundtable discussion to give the global community some of the drivers for odor in Australia and New Zealand, what the cost burden is on industry, why it's important, how it's heavily regulated, particularly around scheduled premises in Australia and New Zealand. So scheduled premises are those that have a license to operate with the regulator, whether that's going to be a state authority like the Environment Protection Authority or a council, depending which part of the country you're in. So I'll just wait for all the former speakers to just join this moderator session. We have run 15 minutes over, but we've managed to catch up. So I commend all the speakers for being very punctual, yet delivering quality content. So while we wait for that, the MOM event was supported by a lot of leading organizations globally. And there's been a lot of effort to get to this point. Carlos did a great job with meshing the network together and bringing in all the professionals. And we all sort of symmetrically and harmoniously worked with each other for the one glorious topic of odor. Of those organizations in Australia and New Zealand, the Clean Air Society of Australia and New Zealand, which is short for CASANZ, is one of the leaders, at least in Australia and New Zealand, that combines and is a repository for a lot of professionals to advance the knowledge base, as well as the training of odor practitioners in Australia and New Zealand. So anyone who pretty much works in odor science and engineering in Australia and New Zealand will be part of CASANZ. I think that's everyone. Hold on, let me just check. Who's here? Alicia. So Alex Todorowski is not here yet. Gary Fink is yet to join us again. Richard, was there anyone else? I think, oh, there's Gary.
Yeah, I'm here.
Alicia. Okay, well, with that said, I might just carry on. First, I'd like to introduce to the global community the CASANZ. CASANZ has endorsed this event, which is the first of its kind, and Australia and New Zealand happen to be the first to nut out all the IT-related challenges in getting this event organised. I think we've come up with a very effective solution in situ, and I'm pleased now everything's running smoothly. CASANZ has a series of specialist groups. Of one of those specialist group is the Odor Special Interest Group, and we're very fortunate to have both the chair and the deputy chair, as well as some of the committee members. I myself am the chair of the CASANZ Special Interest Group, and I have Michael Asimakis also, who's the deputy chair. I also represent the International Water Association, and I'm chair of that Odor Special Interest Group. And we're fortunate also to have Gary Finke, who's the deputy chair. So what I might just do is get maybe Michael to introduce himself both as the deputy chair and for his professional affiliation.
Thanks, Michael. Yeah, so deputy chair, helping Michael with the Odor Special Interest Group. I work for GHD and specialise in obviously air quality and odor science. So in terms of the work that we do as part of the Odor Special Interest Group, we obviously bring together the odor community, so from the regulator space, consultants, councils, all sorts of different areas. We all come together under the Odor Special Interest Group banner. And I don't know, Michael, whether you want me to go into the sorts of things that we organise and run. Would that be a good idea to just give a brief overview?
Yeah, I think so. So things like the Air Talks that we organise, which is a global event. We also organise the biannual conference. In between that, we can also have other seminars and possibly consultative discussion groups for various regulatory changes. I think it'll be a good indication on maybe the Air Talks, Mike. That happens on an annual
Yeah, the AIDIC is, well, it's very similar to this forum in a sense. We do it every biannually, so every second year. We organise a number of talks similar to this. It's all web-based from all the different practitioners that are in the odor space. So we like to try and have a mix from industry, consulting, regulators, and from the universities as well. So try and get a bit of a broad picture of the industry that we're all working in and part of. So we have those talks that we run through the CASANZ broader community, and ODA6 sits within that, and we run them, as we said, every second year. And in the years interim, we do and have now started doing our own ODA conference, as Michael alluded to. First one was in partnership with IWA last year in Hobart, which was a fantastic success. We obviously are looking forward to 2026 with our next conference. Again, we'll be running an ODA conference in parallel to the Clean Air Conference, and that will be held in Cairns in late August or early September next year, which is very exciting. And beyond that, we obviously do run other sessions where there's great interest. So if there are particular changes in regulations, Australia's got lots of different states, so we have various different regulators within each state, and they all have their own ODA guidance or air quality regulations separate to a broader national one. So where there are changes, we looked at holding formal workshops to gather everyone together to talk about those changes and provide input from a community as a whole, in terms of making sure that we're getting everyone's voices heard, and then we can put that forward to, say, a regulator if there are changes being made to regulation, to get that community input. That's probably a really quick overview, Michael. Anything you want to add?
Yeah, look, I think you've pointed out something very important as to what CASANZ does as well in the ODA Special Interest Group. I mean, we're a composition of regulators, air quality practitioners, either from private or public. And that composition and that diversity means when we go into a consultation, we're really involving a community of people with different professional backgrounds, different exposures in various across a various range of different industries. There's also a range of scientists and engineers, and they all come together with a common interest in a special interest group. And that central communication network really helps facilitate a great consultation process. And we're very grateful and very fortunate here in Australia and New Zealand that all these professionals donate their time. We volunteer our time for the sake of really the air quality pollutant, you know, almost odor. We do it for odor. The more odor, the better. So we get richer when the world stinks. So yeah, look, we're very fortunate to have CASANZ support us in the way we do, and certainly also the community members that are involved as part of that specialist interest group, as well as the participants. And we'll get involved also with academia, which is very nice to see Richard, Thais, Ruth, Leisha, and others, to have that just academic space to the equation. Now, IWA's special interest group, we're starting to reignite the specialist group. It's not as active as the ODA special interest group with CASANZ, but Gary and I hope to change that in time. It's obviously a bit more challenging because it's a bit more global. So, and just like organising this MOM event, we're crossing different time zones, so it's certainly challenging to collaborate with others. But Gary, do you want to just introduce yourself and your organisation?
Sure, yeah, no, thanks, Michael. I mean, I just want to say, Michael, you're amazing. The phenomenal effort you put in this industry is amazing. Just wanted to say that. Yeah, so I'm the Managing Director of Cleantech Aromatrix. We design, supply and install air treatment systems. I'm a chemical engineer. I've been in the game for 35 years, so that's a long time in the ODA game, air treatment. And in that time, worked for water authorities, both here in Australia and overseas, consultants and also as a technology provider. So I think that kind of has given me a unique perspective about, you know, the different areas from a client to a consultant, you know, solving issues to a technology supplier. So, you know, I think that is the key. It's like, you know, to solve an odor issue, it's not just one size fits all. You know, you need to understand all the issues associated with it. You know, characterization, what are you treating, what are our objectives to get down to, you know, to get down to a point where we're not causing a nuisance odor. And then, you know, what technologies do you use to treat those various gases? You know, different gases require different technologies. So anyway, so that's an interesting aspect to it. So yeah, look, I'm the deputy chair of the IWA Special Interest Committee, assisting Michael, and yeah, look, it's our objective to really get this that group moving, because there's a lot we can do in this space, not just in Australia but internationally. So yeah, look, I mean, that's probably I can keep going, but I think that's in a nutshell. Yeah.
Well, and it's also not common to have Michael Asimakis and Gary Ficky in the same room. So this is quite a unique opportunity for both deputy chairs to be in the same virtual space, at least. So it's really good. Gary, you mentioned that you've been in the industry for 35 years, and one of the roundtable topics that we like to bring up is, you know, what's driving odor control today? I mean, for you to have a business, I know the odor unit, for example, has been around for 25 years. I'm a chemical engineer myself, and we initially started, when the company first started, we thought all the odor problems would basically be solved in 10 years. Yet we're still solving problems. We're still finding problems, and they don't seem to be going away. Actually, if anything, becoming more complex over time, particularly with urban planning, encroachment, community expectations. So over that 35 years, I mean, you're very young. I know that for sure. So over that 35 years, what have you found were the key drivers for odor control?
Yeah, look, I think one thing that always stuck out is, you know, in the early days, odor was always something that was tacked on the end of, you know, like a project, you know, like infrastructure of a, let's say, a wastewater treatment plant or an industrial complex. You know, that was the main key, is, you know, the system that was, you know, doing whatever, you know, the processing was. But then again, it's like, oh, hang about, you know, we need to think about odor and odor treatment and not causing an odor nuisance. So yeah, so what we see now is really that's at the forefront of the planning. So in the very early days, the concept design, I think everyone's well aware, you know, of what we need to do to ensure we don't have nuisance odors, which is fantastic. The other thing too is, in the past, you know, a lot of it was like, oh, you know, we'll get the suppliers to, you know, solve the odor issue, you know, by determining ventilation rates, you know, what leakage rates, you know, what gas concentrations need to be treated. And that's just, you know, destined for failure, because, you know, suppliers don't have that experience. You know, you need someone to work with a client, like a design consultant, you know, who's got that experience, you know, to work out, okay, let's realistically characterize this issue. Let's decide what are the technologies we believe are appropriate, and basically, you know, set a level playing field for suppliers who don't have that, don't have that understanding in a lot of cases. So I just see that there are two things that really stand out for me as the changes for the good. Other issues too, I think you were talking about encroachment. You know, I mean, you know, population increases. You know, obviously buffers are very important around odor-causing industries. People love to, who probably not in the odor game or don't understand the effects, love to encroach on that. And then we have these issues. You know, sometimes too, you can't get away from it. Singapore's a classic example where, you know, just the real estate, it's, you know, it's such a small country. You need to encroach on these buffer distances for other objectives, other reasons. And hence you need to then go, you know, full on with, you know, odor control, not have those buffers, you know, have complete containment, et cetera, et cetera. So I think we're probably seeing that here in Australia to a certain degree, but also too, you know, as a nation, we're growing, our population is certainly increasing. So there's more, you know, requirements for, you know, dealing with odors, you know, and not making an odor issue for the surrounding community. I mean, I suppose there's some very general ones that, come to mind. There's others, obviously, but yeah.
I think that impact is also being seen across the globe. I mean, the fact that we can hold an event that has global reach, but not only that, but in certain countries as well, the community awareness about odor and its potential health impacts and amenity impacts is driving regulators to potentially reconsider how they enforce action. And a good example of that is Malaysia. They're planning on releasing their odor regulations in late 2026, and when we pass the baton, I'm sure that'll be mentioned by Tan. But the fact that now we're seeing community groups who used to just accept and tolerate that odor's just there. It's just the area that we live in. It always smells. Then now the attitudes are changing, I think, and there's an expectation now. Well, hold on, I can smell it. Is it going to kill me? And even if it's not going to kill him, how is it going to affect my health in the long term? And then you've obviously got also amenity impacts. So is this affecting the price of my property, whether it be commercial or residential? I mean, if you're having an open day and you're showing around a property and all you're smelling is sewage, it's going to decrease the property value. It's like when you walk into someone's house and there's an unpleasant odor, you're probably not going to have dinner there, right? I don't know about you, but that's certainly judging others when you visit their homes.
No, that's definitely the case. Yeah, definitely the case too. And I think people are more aware of their rights. Maybe in the past, you might have an odor issue and you go, oh, how do I deal with that? How do I push back? Well, I can't. And we are now more inclined to go, hang about, I'm not going to tolerate this. I'm going to cause, I'm going to, tell whoever's, like obviously EPA is the first port of call, or councils. And in other countries too, I suppose, we're obviously fortunate in the country of Australia we live in, but in other countries you don't have that, I suppose, that control, that ability to push back. But then I suppose, that is evolving as people understand their rights, and maybe, you see that change globally, so.
Oh, look, I agree. I think it also is a reminder of the powerful effect of odor on the overall human sensory system. It's a very powerful tool to induce a change in behavior, to induce a change of attitude modifications or adjustments, or even emotional. And Richard, do you think that's been one of the drivers today, that educating a population and allowing them to say, listen, if you smell an unpleasant odor, it doesn't necessarily mean you just need to tolerate it anymore. There is actually avenues to improve the air quality that you live in. Over your experience over the past, only a few decades, what have you seen has been some of the drivers for community information, or community drivers for placing pressure on industry to minimize the impact on the environment, particularly from the odor perspective?
Look, I think the main thing that's changed is the industry and the people in it have matured. So I think Gary's point was quite a good one, in that odor was an add-on component, both in the emission area, but also in the drinking water space as well, in terms of tasting odors. And what we've seen, it's become a clear understanding between, well, what are we wanting to measure, trying to figure out what the problem is, and seeing if the technology, it was more of applying technology from other areas, other approaches, either that was measurement, modeling, or abatement. People have realized that the solutions that they've adapted are providing some outcomes, but really are not to the changing public attitude to freedom to express, and which has changed, particularly where we've now got social media, ease of access to either local EPA, EAs, or state federal government. That reactionary component has changed how things are moving along.
Does that include the complaints and the way they're handled? So if I was someone living in the 1970s and I complained to Gary, who's the regulator, would they care?
Look, I think the issue of complaints was still way behind. Complaint collection either by our industry, by us as professionals, by environment agencies, local, state, even federal, is still very, very poor. It's sporadic. It's not consistent. Consultants, government collect all different types of information. We can just see from Geordie's example today, earlier talking about this, what happened there. And I don't see that changing. It's amazing the research projects that we have where we do get access into data, particularly some of the work James has been doing, and it is still poorly designed, lots of holes in it in terms of data consistency. So it's difficult to, doesn't give you value. So we end up going out and collecting. And also a lot of the ways that different consultancies, there's not consistency. That's not something Australia, but that's globally. So Leisha's topic is a great example of people worrying about a measurement, different measurements, really arguing between the different techniques when really the discussion is, how is the benchmark moving? We're always going to have differences between an Apple Watch and a Garmin, which is best, and that's fluxwoods and wind tunnels or complaints. So I think we've moved a long way over the last 20 years, and I've been fortunate to work in Europe and work here in Australia as well, but from a research perspective. So the questions that we're asking are becoming more complex, and they're going in the right direction, but we've still got a long way to go. So there's none of us are going to run out of a job. And my main concern is really what we spoke about in Tassie, and I've spoken about for a long time, is really who is going to be the next generation? Who are the people that you are bringing in, employing into your organizations to really pass on your experience and don't want to be reinventing the wheel every time that we go out and do things, which the industry I see is doing a lot. So it's not great that we've all got different software that's collecting anything, and it's really not giving us a great outcome. But we're slowly moving in that direction, but it's becoming more of an industry within itself, which is a good thing.
Has it been more, Richard, the language in which nuisance has been communicated?
Oh, yeah, that's definitely changed. I mean, we can see that. I mean, it's quite interesting that, because as people became more perceptive, just drinking wine, for example, we've seen that way that people describe things and training people up a little bit has improved the ability to collect information. I don't think that's moved in Australia to the extent that if you look at the data that's collected in Japan through their sensory network, it is so far ahead of us. And we're in air quality and in odor, because they bring it all into one thing. And that's now being operational for using their triangular test, and the number of people that they have receptors out in the community collecting this information. And in some of the European countries, not so much here. Here we do that when there's an issue being raised. It's not background information that we might be collecting over time. Even for utilities that in the waste management industry, that probably should be a bit more proactive in investing in that, so they have background information for when things go wrong. I mean, Australia is slightly different because we're 28 million in a landmass the size of Europe. So we're basically one mega city in a huge area. So it is different, and we do try to translate things from more intense urban global environments to practices in Australia, and there is some differences there that how we should be applying some of the approaches. I've always been interested in, it's less and less now, but industry ringing up consultants and other areas asking for emission data. That's less and less, which is great to see that people understand that what Gary was saying, the individuality of emissions from their sources. But that was always a laughing point, that I need some data for a model, and do you have any data? And you know, in the old days, I just referred them to Metcalfe and Eddy or something like that, and let them end up in court. So you know, that is the difference. But I think that's changed. There's definitely a better understanding of what information you might need to collect and how you might need to communicate. I think communicating to communities around problem sites is still it's a great career path for people that have opportunities out there, and how we work closer with people in humanities and other areas, psychology, that bringing the different sectors together, because those types of issues are not, you know, it's the issue that we've got, how we communicate about nuclear energy, how we communicate about GM products, how we communicate about all different things. That practice is the same. It's the way that the honesty in the components that we're trying to get across, and the methods that we're using. I think we try to make that a little bit too complex.
Oh, look, I agree. And I think in part, it's a shame we don't have a regulator here today, but I think the regulators also play a critical role in forcing the hands of the industry to do something about it, or let alone drive the change. And as a simple example, you know, Environmental Protection Authority in Victoria has introduced the General Environmental Duty. And essentially, for those in the global community, you can be prosecuted for odour. And they can also go for the director and seek criminal charges. And when you get that regulatory shift in the landscape, all of a sudden, industry and others now look at odour as something, not just this nuisance thing that you have to consider in an EIS, like an environment impact statement, or this thing that you just have to collect data from and run a model. It now becomes a more serious thing, like reputational damage, corporate responsibility in protecting the environment based on the sustainability policies or the environmental stewardship. It now becomes more tangible to an organization that, hold on, we don't just have to consider noise, we just have to consider wastewater pollution. There's this thing called air, and in that air component, we've now got this thing called odor, which not all odors are created equally, as we all know, and not all plants are created equally, which adds a nuances to the problem.
I think the other point, when we're talking about engagement, we are definitely seeing a shift in the younger generation, how they look at climate resilience. It's been interesting talking about the political discussions in Australia at the moment, and the generation under us, or a couple of under us, are probably Thais's generation, Lisa's generation. They're not committed to one particular area. They're committed to a topic area, and they will move and shift. And I don't think that we're seeing in government the agility to move and adjust to that rapid movement. And so that's going to be hard. And look, the other thing is, as we all know, we're a very over-regulated 28 million population with local, state, and federal. We don't have a federal EA that can put things together so that we have some consistencies. You know, it'd be nice if we had something that fits around pharmaceuticals or drugs usage across the environment. Would be providing more direct guidance along those. We do have guidelines that come out that they are quite broad, and therefore there's individual interpretations in each state at different levels, and that creates challenges for the communities who move between the states and regions, and challenges for us as professionals to actually have appropriate solutions moving forward. I mean, some people might look at that, oh, that's good business because there's lots of things happening, but I think that's not what we should be promoting. We should be promoting consistency, reproducibility, and so that we don't have these discretions in terms of methods and approaches and things like that.
Yeah, with that said, Ruth, you're starting off the air quality course at the University of New South Wales. What has been your interest from the students that are coming in to apply for the course? more importantly, engage in the course and stay in the course and actually finish it. I'm just curious because it's one of those areas where, I mean, most of us went through university. It wasn't really a subject. It was like this thing touched on briefly for fluid dynamic reasons and meteorological reasons to understand fluid mechanics. But other than that, it was done. It was like over in one lecture. So what have you found sort of the interest in and some of the drivers, I guess? Just your preliminary thoughts.
Yeah, so we're in our second last week of this course. So I've been doing lots of thinking and even building on some of the comments that you were making, Michael, about it's kind of like the complexity of this odor field, and Richard as well, with how the demands of people in industry are expanding. So, and again, based on the fact that a lot of people are probably chemical engineering backgrounds, so like are very readily accepting of systems thinking. So I'm teaching this course to a range of civil engineers and enviro engineers. So I'm really thinking about, first of all, where have the students kind of examined different and brought in different topics. So I gave a lecture this week on air pollution control. So like some of the students had familiar with Reynolds numbers and how you can relay that to particles and see the movement because of fluid mechanics. But a lot of the students from civil in particular hadn't done any chemistry, so they didn't know what Henry's constants were. So I think being able to kind of draw in from the different subjects that they're doing and draw those little linkages is important. Again, you can describe that. So like what happens to a can of soda, different temperatures, you can kind of get into these areas in a way that they can examine. So I think one of the big challenges with teaching a course, particularly if it's over different programs, is what do the students already know? But then also, what are they interested in? So here we have a big transport area and they touch on a little bit of transport emissions, and that's definitely been something that they've been interested in. Also indoor air quality. We've been looking at all of our classrooms and we've got some great examples of like really variable indoor air quality. And like, why does this classroom smell? And we're like, let's go take some VOC tubes and you can see. So I think they've enjoyed that really getting hands-on element. So we had James going and doing some odor tests and like seeing who was the more sensitive. So I think odor is great because everybody can relate to it. Like you can see what was the worst smell you ever smelt, and then you can try and work out what compound it was. So I think hopefully we've indoctrinated some people into the air quality and odor field. But so yeah.
You're almost
anyway,
talking about missing. You're almost referring to that missing link. So I know going into the odor field, there was a lot of discussion about odor transport, but there was minimal understanding with why odor is generated in the first place. And basic fundamentals like understanding vapor pressures, Henry's laws, fluid mechanics. I mean, I'd be surprised if some professionals in the industry won't know about Reynolds number. Yeah, it's a fundamental parameter in atmospheric dispersion. I mean, that should be almost a basis for if you're going to enter the odor field. Here's some 101s you need to know before you work out, before it gets into the gas phase. How does it end up in the gas phase in the first place, and why? And what are the nuances associated with that? And not all odors are created equally. There's a mathematical proof for that. Or not all vapor pressures are the same. So, and I think that's something where people entering this space, at least from what I've seen, need to be just aware. Because some of the times when you're talking to clients and they're trying to get an understanding as to why one side of the plant smells so badly, but the other side doesn't. And then you talk about, hold on, well, you're adding heat here and you're not adding heat there. And there's heat is a driver for various things. And all of a sudden you're talking gibberish to them. They just goes over their head. They think you're this intelligent person with absolute wisdom about why odors are, present, and therefore you can solve it. But really, it's fundamental.
Yeah.
The laws have been around for a long time.
So yeah, having that basis, but also the ability to talk with the community and being able to be responsive to things like sustainability and all of these other kind of expectations that are being piled on. So
100%.
Yeah.
But I see you got an interested facial expression. What has been your experience, I guess, with some of the emerging challenges in the space?
Well, I see first that, 20, 25 years ago, odors were dealt with reactive. Really, if a facility had something, it was ticking the box, have something. Yeah, legislation was there, but it was either not really maintained, or it was really putting band-aids on. And legislation has always been there, but really what is driving is complaints. It's really odor complaints, and that's something. What I see changing is that even odor emitters now starting to see the value of stakeholders around the facility. We have done a very nice example many years ago, where we didn't do anything at the facility, but we just opened the communication with the community around it. And significantly odor complaints dropped just because of the communication. And what you now see happening as well is that stakeholders, they see also the value of the people around them, rather than building a wall, which still happens at a lot of facilities, a lot of utilities, like, we don't want to hear about it. You see a change that they see them as a value, and that they can provide data to to help, at least to mitigate, because it's complex. If an operator works at a facility where they make their money, it doesn't smell to them that bad. But if you're outside and you get these wafts, it's different. And companies realize, trust comes by foot but goes by horse. And so you need to. I see a real change that companies are becoming more proactive, but there is still a lot to do in that area.
I think you've pointed out something very important, though. Attitudes to odor is probably an emerging thing, where if a person is exposed to, let's just say, garbage odor, all of us here will be really interested. What compounds make up this odor? Not all garbage odors are the same. There's different compositions and concentrations of the various compounds. Yeah, when I take new staff on, they go, "Oh, that's repulsive." Their initial response is kind of the response you get from a community member, interestingly enough. Yeah. And then I've noticed over the past 6 to 12 months, you now revisit those places, and their attitudes are a lot different.
Yeah.
They look at it more from a very, I guess, professional and scientific perspective.
Well, we have to understand that the nose is very complex, but a very useful tool, and that is originally developed as a warning signal. And so initial smells are they are perceived as danger, and if you don't know what it is, it's a problem. And so I think educating people really helps. And my experience, and I'm an engineer, I like to put solutions on stacks and things like that. But I think education, helping to cool in the community, include them in developments, etc., is actually as good in many cases. Yeah.
So instead of the fight and flight response, we get fight, flight, or study response. Yeah, that's wonderful. Yeah. Look, I agree. I guess with that said, because the roundtable discussion has considered a number of different important things, Richard did touch on an important point about the future. I mean, there's collectively amongst just this roundtable discussions, there's over 50 years of experience here. How is that 50 years of experience going to actually be funneled into the next generation? I think that's one of the emerging challenges that we're going to have. With that said as well, we've also got the AI juggernaut entering into this all different spaces, both scientific and engineering. And I think us odor professionals need to get a better understanding on how AI can be used to our advantage to both improve maybe the communication side of things, to understanding the problem better. What sort of telemetry are we collecting to feed the AI system? Garbage in, garbage out. So, what are we going to be feeding potentially AI models that are going to be developed in the future. And not just language models, we're talking about potentially AGI, artificial general intelligence, entering into this space. I don't know what the global community is doing outside of Australia and New Zealand at the moment, but I'm sure we have electronic engineers maybe overlapping into the Yoda space and trying to identify how they can maybe assess, analyze, or quantify the problem and make it more predictive, I guess. And that's something I think this space is potentially going to be emerging into. How it's going to look like, I'd open up the forum to people's thoughts on this, but I think it's quite limitless. I think there's a lot of potential for us. We've tried the e-nose, we've tried to replicate the nose. We haven't been successful just as yet, but I think we haven't been successful because it wasn't the right time. The technology hasn't been there to collect and decipher and process the amount of information you need to collect when you're dealing with an odor problem.
Well, I think that the electric nose is overstatement. It's not it's a matter of methodology. It's not the nose developed itself and has filters, and we can't do that with an electric nose. So an electric nose are really useful to see something is changing, but I don't think we will ever be able to represent a nose. It can be helpful. That's all. Yeah.
Look, I agree with your sentiment, although I'm known to be an optimist with technology. So who knows, Bart? Who knows?
No, yeah. What is helpful, I think, is that a lot of the legislation and planning and odor control measures are dependent on dispersion modeling. And these dispersion models and everybody that uses these models is really, it comes down to what do you put in and what model do you use. And if you want to get an output that you like, you will get it. And every consultant knows that. And so it is, I think the future is using real-time data from the field that feeds into that and can fine-tune that and optimize that. So I see there great opportunities there for this space. Yeah.
I agree, Bar, and I think that's where we're also getting some of our global counterparts investing a fair bit of time and energy in working on some of those problems, particularly with real-time monitoring. That's where it's got a lot of value. But I think also industry, because I get a lot of inquiries about real-time odor monitoring. And if it's not H2S or ammonia, then you're very limited about what you can monitor, right? Yeah. And there isn't really a solution other than the human nose itself. Physical boots on the ground, someone going out there and actually collecting the data and then taking it back and post-processing what it means. And that's probably one of the hurdles that real-time monitoring has got to come over, I think. That's in the absence, obviously, of dispersion modeling, which is one pool out of this many. Because sometimes we have to correlate what the modeling is producing versus what the community is actually smelling. And that's one of the challenges I think that we have. Okay, well, that's been, we've covered actually all the topics. So the roundtable discussion was meant to go through what's driving odor control today, how to handle complaints effectively, and we've touched on a few subjects in that regards. What are the emerging problems? I think we've touched on also some of those challenges that are just not unique to Australia and New Zealand, but I think it's a global challenge. And certainly for our population size, I think we're doing a lot, particularly over the large landmass. And I agree with Richard, we are probably also over-regulated for our population density. But hey, good air quality for all in some respects. Then we talked about lightly touched on the smart odor management and is AI being used effectively? And Bart, you've clearly indicated some of the existing opportunities that we have and potentially also how it can be applied in the future and where its effective use is going to be in. And the last one was global career opportunities for the new generation that Richard touched on. I agree that it's great to see some young people around in this discussion. And I hope to see more odor professionals in the future. And look, part of the reason these events are held is to attract the global community, not just seasoned professionals, but also emerging young air quality professionals who have discovered the odor space. I think we all have a story about how we ended up in odor. Most of us will say we fell into it. which seems to be a common theme.
But you love it.
So some fall into it and they either love it or they move out and they carry on with different things. But I certainly think it's a space there that attracts a lot of intellectual demand for someone working in it. It's not easy to work in the outer space from a technical standpoint, from a community standpoint, from a knowledge-based standpoint, and really just overall, it's not like an easy problem sometimes. There's a lot of nuances, particularly with the human factor. I think what makes it complex is there's a human element to our science. And like all scientific subjects, we just like to form nice, neat correlations that add up and get a predictable output. But unfortunately, the community, who our ultimate people that are impacting, it's not that straightforward. So thank you all for participating. We are now going to enter the inaugural passing of the baton. Now, the MOM committee decided on what that baton should be, and Carlos suggested a lemon. So I don't know what the process is for passing the baton. I will digitize this lemon and pass it over to our Asian counterparts. Yes, the technology exists, teleportation. I don't know about quarantine issues, but that's your problem, not ours. So thank you all for attending the Oceania MOM event. It was a pleasure having all of you attend. We hope you enjoyed the topics. We hope you participate in future events. And if there's any further questions, go on the website and look at the MOM event, and you can do some follow-up feedback to the committee. Otherwise, I'm actually not sure about how to pass the baton. So if I could get some help from the organising committee, that would be awesome. We should have had someone from Asia join us.
Well, Tan's online in the YouTube. So I'm not quite sure who's supposed to be picking it up.
I think someone's just joined.
Oh, somebody just joined. Oh, a few more people.
Yep. We'll just wait for the key moderator to join, and we can then pass the baton. Where's your lemons, guys? Come on.
It's up in the kitchen. I'm in the basement, Michael.
I might just chuck an advert and bite into this lemon.
Interesting. A couple of the points popping up are about what he knows is another technique. Yeah.
He knows is
got to understand the issue before you can throw technology at it.
Oh, agreed.
Yeah, and I guess there's that general perception that, you know, as Richard said, if the technology exists, it must be a solution, but sometimes it's not.
Also, I think there's a bit of mindset or attitude towards if a machine outputs something, whether that be a number or some sort of information, that it's correct. And there's this cognitive bias towards, yes, the machine says it's correct, therefore that's the valid answer. And really, is it the correct answer?
Hey, the one thing I remember in really early dispersion modeling was when it went from black and white to color. You know, that was a great move.
Didn't they have black and white when you were young, Richard? Didn't they have colour?
They did. I mean, you know, I remember Mr. Squiggle on the TV, you know.
Oh, Mr. Squiggle.
So who's here? Japan's online.
Yes, we're just waiting for Japan to come online.
There he is.
Hi, Richard. Hi,
How are you?
Fine, thank you. How was the discussion in Oceania time zone?
We had just a very good conversation, I think, about some of the topics that the committee had agreed upon, including, so we talked about what's driving odor control today in Australia and New Zealand. We talked about our issues and challenges with handling complaints, which we understand Japan and Singapore does a lot better in, perhaps. What are the emerging problems that Australia and New Zealand face when it comes to odor technology, odor application, and odor control? We also talked about the emerging AI wave and what AI means in terms of our odor science and engineering. How is it going to impact our space? How can we benefit from it? And where is it most applicable and most useful to use? And then we discussed also global career opportunities for young professionals to enter the space and for seasoned professionals to pass on the wisdom and the learnings in the space so that we can be developing a better future for those younger generation. It's nice to have a handover, in other words, as we ship along and move into retirement.
Okay, thank you.
So, Takayaka, with that said, I will pass the baton to you. The inaugural Lemon from Australia.
Okay, thank
from
you.
Southwest Sydney, I pass this on to you.
Okay, sure, I received the lemon.
Oh, excellent. See, it works.
And you see,
All right.
very big lemon. Thank you.
All right.
Thank you very much. See you all, and I wish you well.
Thanks,
Thank
everyone.
you.
Thanks, guys.
Thank you.
Thank you, everyone.